também chover, pá, chamem-me a atenção para isso.
Sim, não, tranquilo. Sim,
Se eu tenho a apresentação institucional do tema, não era que
exato, essa é a ideia. Essa é a ideia de tentar lançar sementes. Porque o ano passado correu muito bem com outras unidades e na sequência até desse contacto temos a possibilidade de fazer um evento agora conjunto no Vila com o Sessão, sobre o segundo cable. Temos aqui umas aulas históricas que pode ser da Local. Interagindo coisas muito interessantes. Essas coisas, algumas já eram ongoing, mas só nesse momento já trouxe algum reforço da ligação. É isso que a gente quer fazer. Está bem. Somos pequeninos, não você?
eu não sou muito grande.
Está bem, então.
Não sou muito grande.
Não somos muito grandes.
São?
Não, estamos a crescer. Agora a verdade é que
sem ninguém.
ela está como meio altogether. Isto não responde muito bem.
Não vai abrir ele, se abrir eu tiro logo.
São muitas coisas, pá, e também são muitas oportunidades, é preciso estar muito atento. E desse ponto de vista, eu acho que
Então é bom sabermos.
Está com 0 megas. É a única.
Então, mas eu mandei para o...
Se puderem enviar para mim, professora.
Vi agora uma grelha de uma apresentação. Daniel. Assim.
Não, vou ver outra apresentação. Ainda não abri, mas tem.
Mais para baixo, muito mais
Quer se quiserem.
E foi uma sorte ter visto, não é que ninguém ia perceber, mas pronto. Isto demora um bocadinho, o computador é antigo. Um ano faz toda a diferença. Queres fechar ou ficar? É melhor fechar.
É melhor fechar.
Não sei se já dei a hora. Obrigado.
Onde é que está? Não vejo.
ainda não vi o último recorde.
Eu enviei, por acaso já mudei a grade, mas foi dos meus, porque eu nem sequer tinha possível ali a terminar, eu nem sequer trouxe mais computadores. Como ele não se acusou.
Sim, e eu passei, transferi e não, nem sequer reparei. Mas realmente era a única que estava com 0 megas e eu nem me vi. E é chato, é desculpa.
Então, hoje são vocês? Bom dia. Hã? Estás todos? Tudo bem? É porque não tinha desenhos, não tinha desenhos.
Só gravar por cima.
Olha, isto vai começar a ser
Sim. Mas como não sei, acho que é melhor pôr a cabeça.
Quero verificar se está tudo ok.
Eu não fiz um template. Mas vai ser bonita. Já está.
Tudo ok?
Não consigo. A sério, com as imagens que eu tenho, fica horrível. Não fica mal.
Sempre boas expectativas relativamente aos trabalhos.
Agora é assim.
Está quase. Ok.
Não, um bocadinho pesado.
Sim. É mais pesado até agora, acho.
É, tem muitas imagens. Vai ser mais longo. Pesado ou leve?
Esta sala também não é muito rápida.
Não? Até
Os diafones, os edifícios entram.
quase um século para falar consigo. As pessoas dizem-me que tenho que ligar, está bem? Há algumas coisas importantes. Se hoje é.
Hoje é um dia mau.
É?
Eu vou ser o primeiro, tenho que me raspar, tenho uma visita lá inesperada. À tarde tenho reunião do departamento, tenho apresentações. Amanhã vou para a UBI.
Amanhã também
Sexta-feira
estou em
tenho um
Lisboa.
concurso do ISD. Sexta à tarde tenho livre.
Mas não sei se tenho.
Senão estou para a semana.
Não, para a semana. Vamos para a semana. Se me ligar, também não são coisas que eu também. Extraordinário.
Olha uma verificação se está tudo ok.
Se está tudo aqui, não é?
Eu vou ver como é que está. 100% já? Senti que está. Oh, então está tudo bem.
Acho que não. Acho que eles não também, talvez.
Já fui ver.
Eu acho que não é o botão, é exatamente. Esta foto errada. E pergunta, não coordena.
Tive uma avisada desde as 7h30 para a moto da Europa. Esquece que nós temos aqui.
Vitor, catedráticos de segundo.
Algum respeito a isso.
Olha, não estou a aceitar a posição.
Antes de entrar, tira. Só
Às vezes é útil.
Acho que deves pôr no 09.
Margola.
Margola, não é?
Quer dizer, havia mais voluntário, titulada
ficar aberto. Já fica tudo aberto.
Por acaso tu abres as novas.
Ficando aberto, depois é só carregar.
Referência, venham 2 de cada vez. A mim. Opa, quando
Clicar com força que o botão não funciona, por isso é que.
Acontece, mas estas coisas. E o apontador também não está bem. Está?
sou catedrático das ciências de educação e que era conhecido por analogia com os namorados do grande Paulo Jorge. Porque ele discutia a nota final.
Há muita gente pé, estou no centro.
E toda a gente sabia que aquilo havia. Duas gajas que eram. Ele veio parar em cima da secretária. Podia atravessar.
Já não tem direito a mais alguma coisa.
Eu bem fiquei exposto.
Uma coisa é do intro, é aquele grande, mas o outro não era tão lindo. Está bem? Tudo certo?
Pode significar.
Ok. Já foi, António.
Mas eu é. Mete só o slide do
Sim, só o
programa.
slide do programa já.
É grande.
Na altura, alguém que dissesse isso.
Até as outras. Acho que a melhor amiga de uma mulher é o também. As duas foram apanhadas nas línguas. O sofá, depois eu brincava com o gajo ele tinha mandado desinfetar. Este gajo se vai dizer, depois faz Não. Nós tivemos um caso real. Acabou como o bolso dos Estados Unidos.
Isto é agora as
Carregar e arrancamos já.
As unidades estão cá todas.
Como?
Estão cá todas na unidade.
Está lá atrás. Já diz o meu? É só o slide terceiro. É isso mesmo.
Isto aqui é os associados. É o CICECO e o UI.
É a terceira feira.
Ela não está a andar,
Está bom. Não está a poder aqui. Estou a fechar. Deixa-me apresentar aqui. Não, aqui. Exatamente.
Tinha uma aparência jurista e dizia: juridicamente, aquilo era um caso tribulinho que vinha a par, como a gente diz. Lá está, é Fausto em mais de 50 dólares. O contexto familiar.
A chance não obviamente mais é muito grande.
Nem sequer foi.
Agora uma motivação é
O tradutor tem 4 cartas.
Não tem argumentos.
depois das mãos da conhecimento para já está bem. Só há dois com usar mais. Sim. Trocamos. É isso mesmo. Não há jeito.
Mas nem um relatório, nem uma coisa.
Obrigado.
Aquilo arrastou-se, como era Covid, os prazos eram mais de
O apontador está aqui atrás. O apontador está atrás, se precisar.
Sim. Fica ao seu lado.
So, good morning. We are going to start this RISCOday. The idea today is to have presentations from some of research units from University of Aveiro, together with presentations from researchers from the RISCO research unit. The idea is we know each other, we know the subjects and the topics that the others are working on, and also to show what we are doing. At the end, we can try to find some areas of cooperation, and this is the main objective of this session. I don't know if our director wants to say something about
Just a few words.
this section, please.
Okay. So just a few words. So I will be chairing this session with Professor Villarreal. Just to say that this is a continuation of a strategy that we had for the first RISCO Day that we held in February 2022. Basically, the idea is to internally foster collaboration. Basically, what I see in this panel is seeds of cooperation. And that's the whole idea behind continuing this strategy, with having invited other research units here at the University of Aveiro. So the idea is to continue to collaborate. Obviously, there are ongoing collaborations, but I can tell you from last year, it was very perspicuous in the sense that some ideas came up, and there are shared supervisions of PhD students. There are events that will be organized late this month between CESAM and RISCO. So these seeds of cooperation have actually been fruitful. So the idea is to continue this strategy for motivating cooperation. So, Professor Villarreal, we can start whenever you want.
Okay, I will call the first presenter. It will be Professor Fernando Rocha from GEOBIOTEC.
Em contexto, não é? Sim.
Good morning, dear colleagues. First of all, I want to thank RISCO direction to invite me to present you some slides about our research center, the main topics of our research, and the main bridges of cooperation with RISCO. GEOBIOTEC is one of the biggest research units in Portugal focused on earth science. The main points of my presentation, as I told you, sorry, it's advancing. I need that. The main points is short presentations, just 2 or 3 slides on GEOBIOTEC research unit. Then the main cooperation areas with RISCO, some real examples from recent past, focused mainly on funded projects, and perspectives for the near future. GeoBiotech started in 2007, resulting from a reorganization process merging 6 different research units, 3 from Aveiro University, 2 from Lisbon Nova University, and 1 from University of Beira Interior in Covilhã. In our case, Aveiro groups are focused mainly in these subjects: environmental geochemistry and geochemistry survey, environmental geophysics survey, prospecting and characterization of industrial minerals, developing new geomaterials, like for instance alkaline activated materials and geopolymers, and finally the most recent one, medical geology. We have a particular emphasis in what is now calling green mining, sustainable exploitation, remining, reuse, recycling, putting emphasis on new geomaterials and on new applications of old materials. So, our main goals are life cycle of primary raw materials, and on the other side of the coin, the geo-environmental issues related to the first one, and also medical geology studies, not only focused on risk, but also on opportunity. So, transforming a risk and hazard on a new opportunity for new materials. GeoBiotech, and I'm talking only about Aveiro Polo, is the best Portuguese research unit of earth materials in what concerns equipment. This slide shows you some pictures of our major equipments. To show all of them, I will need several pictures. So we have an X-ray diffraction for mineralogical studies, an X-ray fluorescence spectrometer for chemical analysis, a TIMS mass spectrometer for isotopic studies, a SEM-EDS electronic microscope for crystallochemical and microstructural analysis, X-ray grain size analysis for microgranulometry for fine and nanoparticles, a plasma mass spectrometry, ICP-MS, and a gas chromatography, GC-MS, for microchemical analysis, not only of inorganic but also of organic materials, like for instance hydrocarbonates, pollutants and similars. This is a well-known picture showing the development, say in English, exactly, sustainable development goals, in color, the possible participation of earth science in each one. So you can see that we can participate in almost every one of them. Of course, we have a special focus in these two. Number 11, sustainable cities, and number 12, sustainable consumption and production. Since the starting point of our research unit, and I go even older, the starting point of our department 50 years ago, because Geoscience department is one of the first ones of our university, we have a strong link with industry and society. And when I speak about industry, it's not only extraction, mining industry, but also the transformation unit, like for instance ceramics, materials, civil construction, and so on. So we have, and more recently, health. So we are working with people from health science and veterinary, pharmacy. Just before COVID, the Faculty of Pharmacy of Porto University organized a weekend on a very interesting topic, because I don't think that from our part we will be able to put it forward, called geopharmacy. So pharmacy with geomaterials. So it's new topics that we are putting forward. Arriving to the most interesting point, the cooperation with RISCO, I selected as main areas, not all of them, but main ones, with a past, a present, and surely a future. Of course, the most traditional one, rock mechanics, geotechnics, including environmental geotechnics and mining geotechnics. Construction material, including new geomaterials, like I told you before, geopolymers. I'm regarding Vitor here, we are collaborating in several projects. Hydrology and hydrogeology, superficial and groundwaters, prospecting, exploiting, and also assessing contaminations and subsequent remediation, field characterization and survey, including geophysics, near-surface geophysics, risk assessment at field and building levels, and finally, geothermal studies. Some examples, and I selected just a few cases of funded projects from these last 10 years, but representing different fields of cooperation. First of all, it is called Metacal, that was focused on mortars for ancient buildings. B-Earth, focused on earth construction, so rehabilitation. DB Heritage, a database of building materials. GeoSR, focused on cultural heritage, the collection of the Porto Museu Soares dos Reis, and more recently, GeoSurf, utilization of sulfide, a project with Vicente Ferreira, and that is now a second one running. So, reaching the end, what are, from my point of view, our main perspectives for the near future? Once again, not all, but just a selection of 5 or 6. New geomaterials, I think, is number 1. Society is demanding increasingly new geomaterials, more sustainable, less energy consumer, less CO2 emissions, green energy, green buildings with geothermal applications, and rock thermal energy storage. This is, from my point of view, one of main points for our near future cooperation. New approaches for geoheritage, for rehabilitation and conservation of built heritage, using, of course, geological materials. Geohazards, risk assessment, prevention and mitigation, including coastal events. We are on a coastal region. And finally, probably the most holistic one, because this one can include all the others, smart cities, meaning also resilient communities. And that's all. Thank you for your attention.
Thank you, Fernando. I know you have to leave, and because you have to leave, I ask if someone wants to make any comments or any question.
Yes, anyway, yes. I ask Professor Roche about one of those bridges of collaboration that you referred to in the last slide that had to do with thermal energy storage. So more specifically, what could be...
Yes. We are at this moment running a PhD project focused on the use of certain types of natural rocks. For the geology, natural and rock is a redundance, but to be precise, natural rocks to accumulate and after dissipate it. This is not new, it's an old practice, and we know, for instance, that carbonate rocks preserve it much more than a silicate rock. And we see in silicate rocks you can have different types of rocks with different behaviors. Of course, what is new is reliability and the control or the assessment of consequences on, for instance, rock mechanics and other properties of its storage. Okay, so we need to have the advantage preventing disadvantages.
And just a curiosity, because when you're talking about harvesting and storing energy, it's always a challenge to release that energy.
Yes.
Storing is easier than when you have to release it.
Yes.
And in this specific case,
I would say also to release of. In this case, we are focused mainly on it, okay? Not electrical and so on. But we are also putting some ideas for the near stage, because we are not only studying the heating properties, but also the electric ones. What happens during the process with electric conductivity, electric resistivity, for instance.
Any other questions? Thank you very much.
Thank you.
So next one will be Investigadores This researcher from RISCO unit. It's not here, so we can call Margarida Lopes.
So good morning, my name is Margarida Pinho Lopes. I will start by saying that maybe yesterday we got the impression that there was no geotechnics in RISCO, but geotechnics is alive and growing. And what I'll be saying today, I'll be talking a little bit about the use of geosynthetics, a very niche area within geosynthetics for sustainable development. Some of you may not know, but I've been away from Portugal for 6 years and I've returned in the summer of 2019. So I had to redevelop my team starting from scratch. So what I've decided to do today was to show the ongoing work rather than finished work and pointing out possible areas for collaboration with people from other research units. So geosynthetics are polymeric materials that are used in contact with soils or rock, with geomaterials. And they can be used, and I've been focusing on reinforced soil. So the same way we reinforce concrete, we use steel cages to support the tensile stresses, we do the same in soil. So we include sheets of polymer that won't corrode to withstand tensile stresses that the soil matrix cannot bear. So this works similar like pasta sheets on a lasagna. So this is a simple physical analysis. So what I've been trying to do is to contribute to sustainable development by, for example, trying to come up with alternative solutions for infrastructure, mostly recently transportation infrastructure, for example, for roadways and railways. So these are some of the sustainable development goals that I've been working on. This has been done, or is being done, by trying to come up with more realistic and more economic designs, at the same time developing new forms of reinforcement that are more effective, but also trying to reduce the demands for natural materials and the quantities of those materials that need to be quarried. So we're trying to provide alternatives, for example, using wastes or byproducts from industry. My area of work in these last 3.5 years can be grouped into these three main areas. On one hand, numerical models for structures with geosynthetics, using nature-based solutions for soil reinforcement, and also trying to come up with sustainable geotechnical solutions that link well with what we just heard in the previous presentation. With limited resources, I've managed to have 3 students joining my group, and I've recently been awarded a PRR research project that will be a great help. So one of the problems within the numerical models is that geosynthetics have viscothermoelastoplastic response, so a very complex response. And in numerical models, they're usually represented by a stiffness, only that, so linear elastic response, which is far from reality. So what we're trying to do is to enable predicting the long-term response after degradation, after damage of these materials by using simple and advanced constitutive models. So this is the main goal. One of the students working on this is Giovanni Lombardi, and he's supervised by me, by my colleague Antonio Paula from Bragança, and by Antonio Bastos from TEMA, so first collaboration. So Giovanni is working on the mechanical response of the geosynthetics isolated, so the short and the long-term response, to then develop and optimize constitutive models and their parameters. Lucas Paiva, who is also supervised by a similar team, but now from TEMA we have Robert Valente, is working on using both physical and numerical tests to replicate the response of the geosynthetics isolated, but also combined with soil. So trying to understand the interaction and the combined response of the two materials. And this will be then applied to 3D numerical models to represent real scale and real problems, real geotechnical structures. If we now move on to the other area, so the nature-based solutions for soil reinforcement, I had a PhD student that started his work a few months ago, Rafael Anjos, and he's being supervised as well by Professor William Parry from the University of Southampton in the United Kingdom. And what we're trying to do is to come up with innovative forms of reinforcement for railway ballast. So we're taking inspiration from roots, plant roots, to come up with optimized forms of reinforcement. And this will be tested at a small scale, at an element scale, and then in a full-scale rig at the University of Southampton. Lastly, for the sustainable geotechnical solutions, what I'm trying to do is come up with alternatives for both reinforcements and the fill materials. So a recent example that I've published is the use of waste textiles, so jeans that we all use, to be used as reinforcement. So we're using textile materials to reinforce soil. They are effective, they will have issues, durability, but for temporary applications, they are a very good alternative, at least from a mechanical point of view. For the fill materials, we're trying to use pulp and paper industry byproduct to replace totally or partially soils that can be reinforced to promote a better mechanical behavior. As I mentioned before, I managed to get funding from PRR, and I have a project we need a larger agenda, which is the agenda transform. So this is the consortium of companies involved. The particular project I'm leading refers to constructing forest roads using industrial byproducts from the pulp and paper industry, and the project team includes me, our colleague Joaquim Macedo from RISCO, and 2 colleagues from CESAM. So again, an example already of collaboration with other research units. So to conclude, just some ideas for possible collaborations with colleagues from other research units. So I need to instrument the materials, I need sensors, so combining, for example, 3D printing with gyroscopes or other types of sensors that can measure the track movement of soil particles or the reinforcements will be useful. Developing video extensometers or digital image correlation to measure fields of deformation in materials is also a research need that I have, and also using X-ray and tomography to characterize, for example, the changes in packing of particles and reinforcements. Of course, the characterization of waste and byproducts and identifying suitable materials that we can use, and also adding different or more complex modeling tools, such as discrete element modeling, to these problems. And then the product development stage for these optimized micro reinforcements. And that's it. Thank you very much.
Thank you, Margarida. Yeah. Yeah, Sonny, please.
Thank you very much.
Olá.
Thank you very much for your presentation. It was quite interesting. I'm just wondering, because I work with residues and I try to provide them in our work, but I'm wondering, when you are using the textiles, do you have some pre-treatment that is done?
So the initial study that I've developed was without any pre-treatment. So we sourced some old blue jeans from charity shops, so things that people just threw away, and they were being resold, and we just cut them and used them in soil, so with no pre-treatment. Okay, so this was an initial study to assess the potential, because the textile waste is, the amount of textile waste is huge. So that's why I'm saying this was an initial study, so I haven't done that part, and I don't have the skills to deal with that. So we need to collaborate. Yeah.
Okay, thank you.
You're welcome.
Yeah, Carl.
I think the questions are like this. So just curiosity about the modeling tools.
Yeah.
Are you using the specific software?
Yeah. So at the moment we're using Abacus 3D, and we will also use Plaxis 2D. That is able to deal with geotechnical problems in a more specific way.
A very biased question.
Yeah, go ahead. We need those.
You know, a lot of times when it comes to liquefaction and landslides, it's almost like a lot of times, you know, geotechnical engineers, the recommendations they give is, oh, you just shouldn't build there. So it was really nice to see your presentation. You know, maybe the styles can be treated, and then it is possible. I don't know, because again, I know very little about the field, but I'm super interested. Has been, you know, any studies, anything about using, you know, these nature-based solutions or geosynthetics, of course, but in a way to try to reduce the likelihood of liquefaction on that side? So
there are ways to improve the soil performance to reduce the probability of liquefaction. And that includes densifying the soils, for example. So if the soils are denser, with the vibrations, with the dynamic actions, they will have lower deformation. So that's a way without even using reinforcement. So I think one difficulty is trying to identify areas prone to liquefaction before, so you can treat the materials before building. Another way would be to reinforce the soils, but for that you need first to remove some quantities of material to include the reinforcement. So you can add a combination of solutions. So most solutions used so far include vibration, for example, of soils rather than reinforcement. Yeah?
Thank you very much.
You're welcome.
Any other questions? Thank you very much.
Thank you.
Agora é o colega Agostinho Beta. Do RISCO.
Está a poder aqui? Okay. Good morning. My presentation is role pavement materials research in the design option in the relationship between these two topics. I chose these topics and this title because at this moment some PhD students are working in these two topics, and it's a big problem relate with this design the options and the material research relate with the combine the needs of the developing countries and the environmental protection. So the presentation has two main topics. Two approaches that can fall in the road pavement project, and the relation between pavement design option and the pavement research, pavement material research topics. We can, in general, use a design-based way. That is the most common. This is the classic view in order to design road pavements. This approach is based on mechanicist or empirical mechanicist models that from a set of standard well-known materials and service conditions assigns a service life to each pair traffic structure. This is the most common approach. And another way, another alternative way, I named a materials-based way. In this case, the design is centered on pavement performance test. There's no standard materials in this approach. Since the material's minimum characteristic is less restrictive, a wider range of material can be considered in design. Starting from an initial service life estimate, service life can be controlled during the life of the pavement by field monitoring and combined with the digital twins. These two approaches two different needs in terms of the research, material research. In the first one, design-based way, in order to optimize the pavement performance, material must have a standard behavior that has been continuously improved over time. And the material research has three main objectives: to allow, at this moment,
to allow the introduction of recycled material without affecting the standard pavement quality and performance. For example, the partial introduction of recovered asphalt pavement in the recycling process. To research new material for new functional requirements, always ensuring a good structural behavior. And in this case, as example, we have the needs for the special needs for porous and permeable pavements, or high friction pavements, or other kind of the functional needs. And to reduce the environmental impacts of the manufacturing and construction process, maintain the mechanical performance of the pavement layer, of the pavement materials. As example, the war mix asphalt. This for the second approach, in the materials-based way, there's no. We don't need the materials don't need to show us a standard behavior. The material research has the main objective to identify the critical properties for each use. The research, the mechanical properties we test that directly simulate the real condition. Build predictive models and obtain the inputs to PMS, the pavement management system. Finally, some drawbacks and some advantage of each way. In the first way, the design-based way, the main drawbacks are high consumption of natural resources, high energy consumption in pavement production, reducing energy consumption and emission involves a use of expensive additives, requires production technologies and quality control only available in developed countries. The use of materials with unknown behavior in the recycled material waste or byproducts needs additional studies. Main advantage: high and well-known performance pavements are obtained. High confident design for well-known materials and environment condition. While used in developed countries, studied and improved over the time. For the other option, the main drawbacks is the less used. In developed countries, in general, is applied in combination with other approach, namely design approach. Requires some expensive equipment and require advanced training. Advantage: the tests used for material characterization are applied, simulate the real condition or simulate condition or use the field condition. That can be applied at different level, for example, at the initial design or in the rehabilitation design in different times. In developing countries, the initial design can be based on local practice and local materials and improved step by step. The use of materials with unknown behavior, recycled material, waste byproducts is easier and allows take advantage of different materials. So that's it. Thank you.
Thank you. Steve? Any question or comment?
Thank you. It's a suspect, but just a very quick question, Christine. In respect to these solutions and what you're researching on, do you have any perspective on working on carbon sequestration? Because I think that the way that the road pavement, the extensiveness of road pavements and the material used, there's a great opportunity for carbon sequestration in the process, right? And over time, are you looking into that also?
In general.
In general, yes.
I think the environmental problem, it's an opportunity to increase this new methodologies to study, because the classical view are difficult to extend to developing countries because the environmental impact and because the cost. I think these are the main problems related with the design options and the material research.
Question? Something? So the next one is Professor José Carlos Pedro from IT Associate Laboratory from the University of Aveiro with others. How many partners? In IT,
how many partners?
Yes.
9.
In IT?
In the whole IT.
In the country.
We are 9 institutions. We have 30 years of existence. We are, as you said, associate laboratory, creation and dissemination of knowledge, and we are also a center of technology and innovation for the transfer of that knowledge to the industry and to the society in general. Good morning, everybody. Thank you for the opportunity you gave me to present IT. So, as I said, IT is a pluri-institutional institution that has 9 institutions, basically 6 universities, 1 polytechnic institute, and 2 companies. The institute has 3 poles, one in Aveiro, the other one in Coimbra, and the other one in Lisbon, in the IST, the Instituto Superior Técnico, and the largest one is Aveiro. What I'm going to present is not the institute, but some topics that within the Aveiro pole we have been developing that we thought could be of interest to this community. So I will talk about first smart cities, mobility, domotics and sensors, and now I will pass to the smart cities and mobility. For this, I would like to call your attention to the Aveiro Tech City Living Lab. This is a living laboratory that covers, as you can see, let me see if that works. It works. This is the map of Aveiro, and it covers as an infrastructure most part of Aveiro town, in which several sensors are located in several places, and they are all connected by optical fiber infrastructure. That allows IT to not only gather information about environmental and mobility metrics, as well as to offer this infrastructure to the use of other institutions that, for either research or industry, want to use it. Actually, as I said, we have several instruments, sensing instruments placed in smart lamp posts, for example, these posts, or as well as in buildings, buses, and also garbage collectors. We have, as I said, environmental sensors for temperature, humidity, barometric pressure, UV, and so on, and mobility sensors for velocity, number of vehicles, type of vehicles, and so on. And these sensors are based on GPS, video cameras, radars, and lidars. Lidars are, as you hope you know, they are radars based on light and therefore on lasers, and therefore have a much higher resolution than the lasers done with RF technology. These sensors are all interconnected either by the fiber optic infrastructure that I told you, or via Wi-Fi using 5G. This Wi-Fi and 5G is also used to communicate with the vehicles, so that in the future we may have an integrated laboratory in which we have the sensors and the vehicles all interconnected and all of them dialoguing. It's something that now is called IoT, the Internet of Things, that we are promoting to the so-called IOX, which is Internet of Everything. Some examples of data are, for example, the average number of light vehicles, average speed, acceleration, instantaneous counts of vehicles done with the video cameras, and velocity maps within the map of the town, so that, for example, we can see which are the, or where are the constraints in terms of mobility within the city. These are examples of the smart lamp posts that I told you, namely applied to posts, buildings, and even bicycles. We also have sensors for soil monitoring, which monitor, for example, temperature, moisture, and salinity, which for our city is particularly important because, as you know, we are in the middle of a lagoon with salt water. Now I would like to pass to some things that we have been doing in terms of domotics. Well, at this point I should say that for many, many years, and many years, I would say 1 century, electronics was a science on itself. Nowadays, it's mostly, or beyond being a science on itself, it's mostly a commodity that we offer to other fields. So it's no surprise that, for example, when I think it was Margarida that asked Are there any sensors that we can use? Of course there are. And they are electronic, and they are communicating in what we now call smart sensor networks, for example. So, in terms of domotics, there was an experiment in which acoustic sensors, basically by vibrational sensors, were applied to the walls of houses so that the houses can respond to the vibrations and therefore to the knocking or to the speech of people. What we can do with these sensors or to the responses of those sensors is limited only by your imagination. The thing that people were looking into was to design a specific architecture that could secure these domotics. For example, imagine one case in which a smoke detector detects smoke, which may be either real or simply a malfunctioning of the smoke detector, and the response is open all doors of the house. We have to not only take into account what we can do with the sensors, but also what they should not do to prevent robbery and to guarantee security. These are two projects. One of them won a prize that were applied, for example, for the hospital RISCO, which is very close to here, about 50 kilometers, in which we use these technologies to help people that have mobility problems. This is very important, for example, not only for tetraplegics, but mostly for the elder population that we have. Now, I would like to move on to some research and development in optical sensors for civil engineering. First question, why optical sensors? What are optical sensors and why? I make this question because I made it myself. I'm not from any of these fields that I'm presenting, and so my first question was, why optical sensors? And the answer is the same answer that I gave to the LiDARs. That is, we use light because the wavelength is much smaller. We are talking of wavelengths on the order of a micron or hundreds of nanometers, which guarantees resolutions on this level. So we are no longer talking about, for example, displacement of civil infrastructures or civil structures of millimeters, but we may talk about micrometers. And that's why we use optical sensors. What are those? They are optical fibers that have some periodic interruptions, and these periodic interruptions, when they are stretched or compressed, and therefore this A distance varies the response in terms of light. This is wavelength of light. If I input this, I may have in transmission a notch or a reflected wavelength that is proportional to this distance A, and therefore I can measure very accurately the distension or the compressing of things. Where can I use these sensors? Again, your imagination is limited. What I will present is some examples in civil engineering from a project that some of the IT researchers at Aveiro had already with IT researchers of the civil department, civil engineering department of the university. One of these applications is the study of materials. For example, the use of air in concrete. And a test case was done in a church at Aveiro. The image is not very good, but you can see here the interior of the church. Wow. In which several sensors were placed so that we could monitor the distensions or the cracks within the structure. So what we used was these sensors that are supported, for example, in one side and the other side of a possible crack that we need to, or that we want to monitor. And we also can place the sensor, the optical fiber if you want, in case these two sides, this side and that side, are not leveled. We used 5 temperature sensors and 19 strain sensors in that experiment. By the way, these sensors are very cheap because they are made of silica. They are optical fiber. And in the Institute we have already the possibility to impress the Bragg ratings there. We have a laser, powerful laser to make these imprints in the silica. These are some examples of the places where the sensors of temperature and strain were placed, and here you see results for these 3 sample sensors in terms of displacement and temperature. Temperature is more or less always the same. Obviously, the displacement is different considering the position of the sensor as expected. Other possibilities are for infrastructures or for civil structures like bridges, for example, and so we held a project in which real-time structural health monitoring using fiber sensors was done. We used 400 sensors of temperature, deformation and acceleration, and they were solar powered so that they could be there almost forever, and we could do the remote sensing of these sensors because as they were powered by solar energy, they could transmit the data to a center, and then remotely we could monitor in real time what was happening. These are some examples of one bridge in the A17 freeway that we have very close to Aveiro, in which these sensors were placed to monitor the health of the bridge. This is another example of another displacement sensor in which with this we can see, for example, the displacement in the vertical direction or with this in the horizontal direction. And these are the examples of the solar cell to power the system, the control of the sensors that allows us then to transmit information remotely, and the bridge where this was placed. And that concludes my presentation. Thank you very much for your attention.
Thank you, Ricardo. Thank you. Any? Yes, please.
I have a little bit of experience in laboratories with acoustic emission sensors and digital image correlation for health monitoring.
So acoustic sensors and
digital image correlation.
I'm sorry, could you please repeat?
Another type of health monitoring which depends on the camera, so we can detect the crack,
Okay.
for example. So what makes the fiber sensors, like what are the advantages exactly with the fiber one?
Well, I can tell you that in my institute, not necessarily in Aveiro, but for example in Lisbon, we have people working with other types of sensors for detecting cracks, namely, for example, in metals. Okay? So there are, as you say, various types of sensors. What I believe is the advantage of the optical fibers is the resolution with which you can measure things. For example, imagine a crack. Okay? You want to know if that crack is making like this or like this over time. Okay? And the movement is very slow. So in 1 year, it may move, what, 1 millimeter? And you say, no, I don't want to wait 1 millimeter or 1 year. Can I have a measure of this in a much shorter amount of time? Yes, as long as if I can measure much smaller distances or much smaller deviations. Optical fibers allow you to do that. It's mostly a question of, as far as I understand, a question of resolution. By the way, for example, optical temperature sensors is the same idea. They are based on dilation, okay? Caused by temperature, and you may say, well, the dilation is very small. Yeah, but the resolution that I have is very, very small. Is micrometer. Is tenths of micrometers. Okay?
Thank you.
Just one question and one curiosity about things you have presented regarding GEOBIOTEC City Living Lab. Is it possible to install additional sensors like, I don't know, as looking for the sensors you referred, for instance, carbon monoxide sensing, because I imagine you have talked about temperature, but I haven't seen anything referred to pollution-related sensors. Is it something that it's easy to install in the system, any kind of extra sensing that would allow new projects or something like that?
The first question was much easier to respond than the second one. Because the first question was, is it possible? And the second question was, is it easy? Well, first one, I know what to answer. And the answer is, yes, it is possible, and it can be done as long as you can convince us of the utility of that. Our objective is to, well, we built the infrastructure, we invested a lot of effort and also money in doing that, in cooperation, by the way, with the Câmara Municipal, with the mayor of the city, but it is owned, so after investing on it, we are interested in taking use of it. And so if you say, for taking use of it, I would like to have these sensors, yes, we'll do it. If it is easy or not, that it's more difficult to say because it depends on the sensors, it depends on the way they should be placed mechanically and how they should interact electronically so that we can get the information. But in case you are really interested, send me your contact. I'll put you in contact with the person that is responsible to that, which is Susana Sargento.
And does that field talking about decarbonization of cities that will come out as an important issue until 2030? I think it's important.
In fact, I mentioned already.
Motivate the city itself to control its carbon emission rates in this.
No doubt. In fact, I mentioned in my presentation that beyond the mobility, we had the interest, and we are already, or we have already, environmental sensors for that. So if you say, well, the sensors that you have are not enough, we would like to add this into the infrastructure. Of course.
Thank you.
Thank you very much. And by the way, if you want, you not only may retune the infrastructure, as you can use the data that has been collected by that infrastructure. Okay? Thank you very much.
So the next one is Inês.
Good morning. So I will present some work towards water management solutions. So we all know that it's a worldwide objective to move towards decarbonized societies, and we can only do it if we tackle all the parts of a city, and in here I will focus on decarbonizing the urban water cycle. And particularly, I will say that if we save water, we will also save energy, because we need energy to transport water, to treat water, and also to heat water inside our homes. So if we are saving the water, we are saving also energy, and we are reducing the carbon emissions. And particularly, I will focus on, when talking about reducing water, I will talk about the urban scale on water losses reduction in the urban infrastructures, and also on sustainable water consumption related to the efficient use of it and alternative sources in buildings. And particularly, so this is connected with what we were talking, if we have access to so many sensors, the way to have more reliable water management solutions, it will be through data-driven solutions or methodologies. So I will give an example of a project that is going on, that is Water Data Solutions. And basically, the aim of it is to create an innovative, intelligent monitoring system that will focus not only in the urban water distribution networks, but also on the water consumption inside buildings, particularly houses. So we are dealing with two case studies, one in the Aveiro region and the other one in Miranda do Corvo. Very different, especially the urban situations. The second one is much more rural than Aveiro. Aveiro is very different between the city and the other parts. And we are monitoring in Aveiro 2 district metering areas, and in Miranda do Corvo 7, and also in Aveiro 25 houses. So the first objective is to detect water losses and it is through water flow data that, through statistical analysis, allows us to determine consumption patterns, and when we are out of it, to try to see if we can detect leaks. So this is an example of a pattern during a day, during a week, and then just an example of a potential leak where we see that the pattern changes in that time, and then it comes back because we have a repair. Then the second objective is related to the efficient use of water consumption in households. And what we wanted was to broaden the project and to think first on the influence of the user's specificities on water consumption. So a house that has 5 people has different consumption per person than one house that has only 1 person, because of scale savings, and we have many other characteristics, not only of the household, but also on the characteristics of the dwelling itself. Then we are also starting to have water consumption data to be acquired. These are just some examples to show you, like the ones on the left are from cistern flushing, so half flush or complete flush, we see the differences. Then on the right, we see some data for hot and cold water consumption along several days. So the idea here is to play with artificial intelligent algorithms, to be able to have a consumer profile, and with that help people in 3 different layers. One is to allow this person to compare its consumption with similar houses and similar households. So through gamification, people only knowing what they are consuming in relation to other people that have similarities, it allows to be more sustainable with their consumption. Then the second 2 are recommendations that can be done when we know the data more specifically, because we can say that the person is using more water, for instance, in the shower, so helping to have a behavior change, or we can see that there is a leak, or that if they would have rainwater harvesting, that they could save a lot of money or of water. So the third one. So the idea here is to have an application where people can see in their phone or in their computer how is their data and how they compare with others, and if they can have recommendations to improve their water consumption. So these are a lot of things. Some we can go till only a certain point. So for sure, having collaborations with electronics are always a good thing, because everything is improving day by day, and sometimes we can only have some households being monitored and in a small time period, because the sensors are expensive, or because the connections are expensive, or because it is difficult to implement, because we have water, and sometimes we have to interconnect the sensor inside the water system. So lots of things that, if they can be improved, we will have more data to analyze, and we will have solutions that are more capable to represent what we are doing and to be sustainable in the future. Thank you.
Any question? I have a question. So it's a great example of human-centric research. I will ask you about the future, because I think that it's very interesting that the slide on the gamification, and how you think that that will change the human behavior, because human behavior has to be awarded at some point.
Yeah.
And how can we award people with this? Because it's really interesting, this approach of changing human behavior, but you have to award it at some time. How are you thinking about this?
Yeah, I've been working with some colleagues from social sciences, design. So what we see with other gamification with other areas, even without being water, is that people are concerned, and if they know what they are doing, they can improve. Of course, we have at the same time another thing that is very easy for us to have a sustainable flushing system, because you don't think on that. If it does the purpose, that's it. But if you think, okay, let's go from a 10-minute to a 2-minute shower, then you have the problem. So I can tell you that I 1 month ago in the water day, I was in Ilhévo in the museum, and I was with 100 kids, and I put them, I didn't put here, but I put how can I say, I played with them to see how could they save water. So was it with gamification? Was it with reducing the amount of euros that are paid by their household? And actually, it was quite interesting, because they were higher level in high school, and they were actually concerned with the money. I was not thinking on that, because they don't pay the bills. But they said that if they knew that they were wasting water, that they could contribute to reduce it. That was one thing. Another one is I also put them concerned with the animals. If you are having an extinction of animals and everything, what do you think about that? So they will be a little bit guilty, and they will think, okay, I will try to save the world. If it is with a smaller amount of time shower, I will try to make the effort. So it's very difficult to have these responses. But what I see is if we have the sensors, if we have the capabilities, we should have it to change the mindset, not only human, but also on our systems. Because we can also see another thing is people are always thinking, is rainwater harvesting worth it? Maybe if they see the data, they will start to think, okay, I will save money, or even if I don't save money, if it is almost the same and I'm saving the world, maybe I will do it. So it's a question of showing the data to people.
Can I have a comment? You know, very interesting. Then I talk to people from energy, they also have their own systems. And then I go to the medical school, they have also their own wishes. What is really missing, and I think you are in a unique position, is integration. Because in the end, it doesn't make sense to set up a system only for water, other system for energy, other system for health or whatever, other for structural monitoring, and everything makes sense. But the problem is, how can we integrate? And then I think your question, it's how can the user handle all these? We are already on information overload. I think I am. So, but you have this tremendous capability of the IT Institute. You have, everybody here was talking about sensors, and you need sensors for your fire and for fire safety and so on. So, and so far, we don't have, I haven't seen anything on IoT that really makes sense to me. They offer me another day one system for me. I was able to turn on the coffee machine from here, but the coffee machine in São Paulo is not very useful for me now. Or turning off the lights on the living room being on the dormitory. And then you have, so maybe this could be something very unique from RISCO. You have the companies, you have, because this interests not only to the user, but also to the utility, to the city council, to policymakers, to researchers, to everything. I don't know.
I think it's a great challenge for IT corporation.
No,
with
for
the
IT is commodity.
Is how to integrate all these signals that we are getting.
It's not the IT. It's something from engineering, from architecture, from people. Yeah. Because he told it's commodity. They have the sensors. They can do anything we want, what we want, as a system that we can add in a house. That should be integrated. We need, so that's, I think, it's a worldwide missing opportunity. It has to be cheap. It can't be very expensive.
Yes, that field is, or the topic that you are reading is very important, and it is already studied in my community in something called sensor fusion, that is using several sensors, monitoring different physical properties, and then fusing all this data and producing data from the original one that is understandable and more useful to the user. There is a topic of research nowadays.
Yes, very small, because I also work with gamification and with this human-centric, as you mentioned. I wonder your experience on, because there is a difference between if you have such watch and he is just collecting all that data and you don't mind sharing and you give your privacy, yes, no, and that's okay. On having systems where the customers or the users have to input data, and that can work by rewarding, but in a certain time it vanishes. And I wonder your experience if with water is different,
yeah.
Which I wouldn't expect it is, but anyhow, everything that it demands an effort, with time the data gets slower and more even fast. Just fill in and that's it. While in the beginning maybe you have more quality data.
Yeah. This part is in the beginning, okay. But we have the experience of others. So we see even the users, they get tired.
Yeah, exactly.
So of course they can think, okay, I will save the world the first weeks, then I don't care. but we try. Yeah. So that's one. But that's why I said that's only one of the objects.
Yeah.
The objectives. The others are more engineering directed. So are more to know which are the optimal solutions for each household, because it is different. For one, maybe it's rainwater harvesting. For another one is reusing grey water. For another one is having more water efficient shower heads. So we can have with everything, because it's what Professor Vanderlei said, you have so many things. So I just want that you give me some smart and very few advices. So I think what the users want is just 2 or 3 that they can do in 1 year or something. They don't want everything every time. So in here is more time consuming for the users in the first days, because we want to try to train the water consumption. Then after people give us some data, what we are trying is to see if it plays by itself, and that we understand where is water being consumed. Because the problem is in here is water is cheap, but at the same time it's much more difficult to track than electricity. And that's why we have much more apps for tracking electricity than water. This is more difficult.
Sorry, please.
Just a small, do you want or do you have the intention to try to transfer this type of project for agriculture, because agriculture is one of the biggest sectors wasting water, and they may have some solutions to be more accurate in the use of water. So just a curiosity.
Yeah, we were not, because we are still in the process of this one, but of course that's a big issue. Although we have
we use lots of water in agriculture, but we use lots of energy in the city, because we have to transport, we have to pump it with pressurized water, we have to heat it. So it was more focused on the cities, but of course that's another thing that has to be thought. So here is more to show you an idea that is even starting. So anyone that wants to think about something, we can interconnect, because we all know what we are doing is research, so it's a life-going job.
Okay, thank you very much. So next one is Joaquim Macedo.
Slowly. People will speed up. Say nothing. Just really great.
Good morning, everyone. I will present some of the work that I've been doing in the last years. That is basically microscopic simulation applied to traffic engineering. So I will present to you some examples of applications that were done in cooperation with some colleagues of the University of Aveiro and other institutions. So this is the outline of my presentation. The concept of sustainable mobility. Everyone knows the concept of sustainable development, and this is the concept applied to sustainable mobility. So the ability to meet the needs of the society in terms of mobility, people and goods, but without sacrifice essential human and ecological values today or in the future. So basically it's the same applied to mobility. The importance of the topics, and I brought some numbers because I think that are important to see the context. The transport needs, so they are increasing. Two dates where we had outliers, the crisis of 2009 and the COVID. So that are the only outliers that we have. This means that in terms of energy consumption, we have 28.4% of consumption in the transport sector. So it's the third, in this case the second, it's the third in terms of emissions. So we need to look at emissions, and we have 23.2. But this was the year of the COVID. So we have slightly difference from the base. And that is visible here in terms of the trends. All the other sectors are decreasing the emissions, but the transport sector, of course, the COVID brought to us a decrease, but it was, as I said, an outlier. We continue to have, in some cases, a slight decrease, but again, an increase in terms of emissions. So we need to look to this problem. And inside the transportation sector, of course, the big part is the road transportation. So the other transport modes, of course, aviation, it's important. Navigation, it's very, very important. Railways, it's the best in terms of environment, but the problem, the big problem is in the road transportation. And in road transportation, cars. Around 60% of the emissions are due to the private car. There, I don't brought that number, but it's worst. In terms of transport mode, for example, in Portugal, we have around 85% of private car use. So, car is a problem. We have this right now, but we need to change the way we move. We need to start to use more sustainable transport modes. So, in this context, I use, and the persons that I work with, we use this type of software, microscopic traffic simulation, to try to test some strategies that we can use to change all these contexts. Some advantages of these tools, we can do many scenarios in the totally controlled environment, so it's good. We don't change anything in the real world. We don't have any impact in the systems. We can also, and with the more advanced models, we can model the interaction between all the transport modes, and it's very good to sell some ideas to politicians, for example, because we can show how the traffic moves in the network and easily represent and show the results to non-technical audiences. And I brought to you some examples that were done with colleagues, in this case from Instituto Superior Técnico. This was the work that resulted in the master thesis and also in the publication. We model a zone of Porto where are several kindergartens. So the idea was, okay, we have the kindergartens. In the morning, the fathers leave the children. In the afternoon, they pick up them. But we also have loading and unloading places that we can use, and in the morning they are empty. Okay. So the idea was, okay, let's use in the specific time period, using a concept of shared economy, let's use that places to the parking of the fathers during a very limited period of time. That was the methodology that we used to do the simulations, and the results were a reduction in the travel time, about 11%, and reduction in stop time, length of the queues, fuel consumption, and also pollutant emissions. So we achieved all the goals. This idea, this concept was used by the municipality of Porto, and right now with some changes, of course, they use almost in all schools with a strategy that is kiss and ride. The second example that I brought was work done with the collaboration with TEMA, with Professor Margarida Coelho, also a master's student, where we simulate and try to test different strategies, different mobility strategies, in the relation between the city of Aveiro and the port of Aveiro. So we construct the model. Of course, we need to pass all that steps of calibration, validation, and so on. And with the model calibrated and validated, we test 3 different scenarios. The first one, electrification, so replace some conventional cars by electric vehicles. Then we test a second strategy that was digitalization. Why not some of the workers work remotely at home, and what is the impact of that? And finally, the concept of mobility as a service. So it's a new concept. It's in Portugal, the only place that we have this concept with some maturity is Cascais. But we thought, okay, let's try to think in the concept of mobility as a service applied to these trips. And our students, with some imagination, conceived that scheme of different trips using basically buses and also micromobility, bicycles and scooters. So the results lead to us, with the electrification, a decrease in the emissions, but not in all the scenarios, because the trips from Gafanha, we had an increase in the emissions. So electric cars are good, but in the short distances could not be so good. Why? Because we are thinking in the life cycle assessment. So we studied the emissions during the production of the car, the operation, and also the end of life. The second scenario led to us to a 22.8% reduction in the CO2 emissions, and this was based on the survey that we conducted to the workers of the Port of Aveiro. So, of course, some of them, it's impossible to do their work remotely, so we only could change the habits of the workers of the administrative services, but even with that, we achieved a significant reduction. And also in the concept of mobility as a service, we, of course, we achieve a very, very high reduction, around 90%, but of course, here we consider that all the workers use this service, okay? So it's more or less an expected result. Finally, and this is new, it was a master thesis that ends last year, and this urban logistics. So basically we try to analyze the operation and social and environmental potential of use of drones. So urban air mobility to distribute the goods within a city center. We also make the comparison with cargo bikes because it's also a transport mode that we can consider a sustainable one. So this was the study area, the same that we already used in the first example. That was the methodology used, basically the same, with a different part, the public acceptance. So we also try to know what is the public acceptance of this type of strategy for urban mobility. And the simulation models that we used, basically the same because there are some issues related with the overfly zone. So to don't have that problems, we use basically the road network. And the results, after a sensitivity analysis, we tested that 4 scenarios and we achieved the best solution with a substitution of 4.5% of conventional vans by 2% of cargo bikes and 2.5% of drones. So with that, we can conclude that it's possible to improve the mobility also with this type of strategy. Some final remarks. So if we want to decarbonize the mobility to improve the quality of life, we need to change the way we move. We need to use more sustainable transport modes. And also the learned from the pandemic. The pandemic highlighted some new mobility challenges, the restrictions that we felt. For example, in the public transport, that is, of course, a very good and sustainable transport mode, but by health issues, some people avoid it. The tendency to increase the use of individual transport by private car was also saw. So all the way that we already have done was more or less jeopardized by the COVID. The opportunity to increase the use of more sustainable individual transport modes, but not the car, for example, the bicycles and the scooters, and finally, the remote working. So what it was also a learn from COVID, remote working and distance learning. So apply not only in the side of the offer, but also in the demand. It's important and it decreases the mobility needs. So that is it. Thank you very much.
Any question? I have a question. Joaquin, very interesting. I see that obviously this is very valuable work that can be used for obviously more effective urban planning. Do you have any insight on, for example, how maybe you can bring into this, into the research geoinformatics, and specifically remote sensing to give you, big data and a lot of data? to go from that micro modeling to a macro modeling.
Yeah, I think in data, not in that perspective, but more in terms of the calibration and the validation of the models. These models could give us what we want. So we need to calibrate well and also validate well these models. I always say this. And of course, for example, the sensors that were presented and all the environment that we have, the infrastructure to collect data and feed these models is essential. So without that, we cannot have good models to do the tasks that we want and to design new strategies for sustainable mobility.
What are the limitations to use drones to deliver?
Drones, for now, it's a little bit difficult because...
you know, what are your expectations about that?
I think that is a role, that will have a role, but it will not be the magic solution. It will not. For example, the SEIA, that is an institution that collaborate, they already have some tests, for example, in the medical applications. For example, to pick up an antidote to a snake antidote from Hospital Saint João to other hospitals and so on. So that type of application, it's very obvious, but in urban mobility, we have some problems now because we have the fly zones and so on. So we need to first have a regulation for that, and then we'll search the applications.
Okay, thank you. Okay, thanks. So, next one is Professor Ruth Ferreira. No, sorry. Sorry, Professor. Okay. Ruth Ferreira from the CICECO is an associate lab.
Okay, so good morning. Thank you for the invitation. It's a great pleasure to be here and to present part of the research on spectral converters for building integrated photovoltaics and the Internet of Things. As it was mentioned, I come from CICECO, and I will start this presentation by a brief introduction on our associated lab. CICECO mission is to create and disseminate scientific and technological knowledge to develop, process and apply materials that will anticipate and address the challenge of a global society. CICECO is an institute located at the University of Aveiro. We are spread all over the campus, at the chemistry department, in the materials and ceramic engineering, and also in the physics department. In the total, we are above 445 people. From them, with a PhD, we are 175, 42 academic staff, and the majority are researchers with a PhD. CICECO focus, we give emphasis to 3 topics: sustainability and circular economy, renewable energy production, storage and carriers, and biomedical science and engineering. And my last slide about CICECO is CICECO structure. I will not go into details. It will be my pleasure to discuss CICECO after this presentation. I would like just to highlight our 4 research lines. Research 1, information and communication technology. Line 2, energy and industrial applications. And sustainability and health. I am a researcher at the research line 1. And my topic of investigation is photonics. Because I'm here with, some of you know very well what is photonics, but it's in fact the science and technology of generating and harnessing light and other forms of radiant energy whose quantum unit is the photon. Photonic contributions are considered sustainable, the so-called green photonics, if they generate or save energy, reduce the greenhouse effect, reduce pollution, and promote a better and more sustainable environment. For this topic, I select one example of my research interests that combines sensing, in particular real-time monitoring with smartphones, mobile sensing, with photovoltaic conversion, in particular the use of luminescent solar concentrators. The motivation is very well known. The use of clean and affordable energies is a crucial change to tackle the action on climate change, and we know that nowadays the energy is mainly consumed in three sectors: buildings, industry, and transportation. In what concerns buildings, they are responsible for 40% of the energy consumption, and if we want to measure it in CO2 emissions, 36%. In line with the United Nations, the zero energy buildings are a target for the new buildings. Part of the energy policy, in fact, in several countries. In Europe, by January 2030, all new buildings should follow the requisites for zero energy buildings. In fact, the requisites include integration of renewable energy sources, selection of efficient devices, and then the systematic evaluation of opinion about buildings in use from the perspective of the people who use them, the post-occupancy evaluation. Nowadays, the solar energy is the dominant renewable, however, is unable to cope with all the energy needs. And this is very clear why in this graph that showed to us the contribution of panels to the energy needs as the number of floors increase, as the buildings get taller. It is very clear that in our cities, the rooftop will have exactly the same size independently of the number of floors. So how to solve this? One strategy that is already in there is the build-integrated photovoltaics. Nonetheless, several disadvantages prevent it to a widespread use. Of course, the silicon panels are opaque, therefore they reduce the sunlight inside the buildings, and the public acceptance is poor because of that. From the technical point of view, under these conditions, the photovoltaic conversion efficiency decreases, of course, because of shadowing, cloudy weather conditions, for instance, and orientation of the facades. So one of the limiting factors for this lower efficiency under these circumstances is the mismatch between the solar irradiance on Earth, that is represented here by this spectrum, and the silicon absorption. Only 40% of the light available on Earth from the sun could be used by the silicon cells. So it is very clear that there are part of the solar spectrum that could be used for downshifting, down conversion, and up conversion mechanisms. So the idea here, without going into technical details, we need to shape the incident sunlight through adequate spectral converters. We propose to do this using luminescent solar concentrators. A luminescent solar concentrator is in fact a transparent substrate that is doped or coated with that luminescent species that are able to absorb the sunlight and downshift it to longer wavelengths that by total internal radiation are guided to the edges of the substrate where they can be collected by photovoltaic cells coupled to the edges of the glass. So the idea is that we can use the current design of the windows, and the luminescent solar concentrators can be designed with the tailored shape, color, flexibility. They are transparent. They behave analogous. They present the same spectral conversion and they diffuse all direct radiation, contrary to that of the photovoltaic cells, and they have a very low-cost implementation. So the idea is very simple. Our idea is to convert the facades into power-generating buildings. With the current figures of merit, power supplies up to 10 watts per window are feasible, granting, for instance, the supply for low-power devices such as the IoT devices. Here is an example of a possible photovoltaic urban integration. These are colored plastics and colored glasses panels on the facade of the Palais de Congrès in Canada. And if all these glasses will be turned into luminescent solar concentrators, we can have an attractive electricity generators. And it is not difficult to think about this if you look all around the world where we have many examples of buildings where the facades are already colored. In any case, today I will give emphasis to transparent luminescent solar concentrators. Typically, as I mentioned, we select the appropriate emitting centers. Typically, we use lanthanide complex and synthetic organic dyes. What are the requisites? They need to absorb the sunlight, so this shadowy colored spectrum represents solar radiant on Earth. You can see that they are able to absorb in the visible, and then they convert that radiation to longer wavelength, shorter energy that can be absorbed by the silicon solar cells. That orange line represents the absorption of the silicon. And so we follow two approaches. On one side, we deposit on the top of the commercial solar cells our material. Remember, they also collect diffuse radiation, contrarily to the photovoltaic cells. And also we frame all the film with other photovoltaic cells. To show to you the effect, this is a photograph of one of the films. You can see that light emitted at the surface is clearly concentrated at the edges of the substrate, and the surface is transparent. So let's look at this small prototype. So we coated with a layer, and then with the flexible solar cells, we also frame we give extra photovoltaic conversion material. And here I have this thermal quantum efficiency of this photovoltaic cell, and we compare with only the coating. You can see an increase in the response, in particular in the UV spectral range. And if we combine the both effects, you can clearly see that we have an enhancement of the photovoltaic conversion, in this particular case of the order of 13%. We also want to address the aspect of increasing the size of our devices. We follow several strategies. One strategy was by using optical fibers. Typically, we use optical fibers that are bulk. So the idea was that we coat them with our material, and we also use hollow core plastic optical fibers in which the material that will convert the sunlight is inside the nucleus of the fiber. And here I show to you some photos of the real prototype. You can clearly see the light concentrated at the edges of the fibers. Of course, this approach is also very important for remote light harvesting, if you want to collect sun in a position different from that where it will be used. Another way to increase the size of our devices is, of course, to assemble all these fibers. So we slightly change the shape, we make it slightly triangular so that we can couple them with more efficiency. We increase 7% the photovoltaic cell coverage. And here again we have some photographs of our prototype with different colors, meaning with different emitting centers. And here we have a mixed bundle just for a proof of the concept. And here this video showed to us what. So here I have a commercial silicon photovoltaic cell. Here I have our bundle, and this is illuminated under a solar simulator. And here these numbers that you see are the short circuit current of the cell. You can see that while you are moving back, the short circuit current is decreasing, okay? And while you are approaching the luminescent solar concentrators, you can see the short circuit current increasing itself. It's just a demonstration of the working of these prototypes. But okay, the future of the luminescent solar concentrator. Of course, we want to focus on performance. We want to enhance optical conversion efficiency and the power conversion efficiency, of course. We are in Europe, and we must remember that use of lanthanides, for instance, is not it's something that we want to avoid because these are critical materials in the sense that the control is outside Europe. And of course, we want to move to sustainable process in which we want elimination of toxic metals and we want an easy recycling. Because of that, we follow a different approach. We replace the synthetic organic dyes by luminescent organic molecules extracted from renewable and natural materials. So we have larger synthetic versatility, we have high absorption coefficient, and also high emission quantum yield. So one example that involves a molecule are phycoerythrin extracted from amalto-algae. This was our initial first approach to sustainable luminescent solar concentrator, and here I just want to show that this pigment can really absorb at least 12% of the solar irradiation on Earth, which is a huge amount of photons. So here are again the photos of our prototype. We made it in fibers and we made it also in a planar shape, and you can see that we can end up with optical conversion efficiencies nearly to 7%. I start this presentation by mentioning zero energy buildings, and another very important aspect is the fact that the 40% of energy that is consumed, 64% is related with heating. This means that the temperature sensing and user awareness, as it has been already spoken here, is very important. So what I will propose is that we upgrade the concept of a luminescent solar concentrator and turn it into a real-time and synchronous temperature monitoring that is powered by the sun. So a self-powered optical sensor. Another aspect is that we also propose to monitor temperature in the walls. Okay, our pigments are easily transformed into inks. They are transparent and they can be placed all over the building, inside and outside the walls. So, how do we do this? Typically, we use luminescence thermometry. The main advantage is a non-contact, is a remote operation. He has high relative thermal sensitivity, high spatial resolution, short acquisition times, and it is immune to electromagnetic fields and other harsh environments. In fact, it's the advantage of the optical sensors that was already mentioned here. So typically, the thermometric parameter that allows to quantify temperature is made by conventional spectroscopy, where typically you use a spectrometer, you need to go to the lab, and you use the lifetime, the peak shift, the intensity. We don't want this, of course. No one wants to carry a spectrometer into a building. It's not portable. So what we decided to do was to use smartphones as a key element. Just remember that smartphones are, of course, ubiquitous technology. They have a large processing capacity, and they are able to do something very important, convert optics into electronics. So our idea is very simple. We have the smartphone. The light excitation from the flash can be easily used. We have the detection, the CCD camera, and then the material color change with temperature will be, let's say, the physical mechanism that allow us to capture a photograph, analyze the RGB color components, and then quantify the temperature. Let's see how this works. Just to tell you that some of the inks, we process them as QR codes because they are a privileged tool to link the optical sensor to the IoT. Imagine all these walls with a QR code that was printed with transparent inks, and all the smartphones of all of you could measure temperature in real time and again send it to a database. So again, we decided to go to a sustainable approach. So this time we use green fluorescence protein and phycocyanin. Again, those two molecules, they were selected because they absorb the sun in complementary spectral regions and they emit also in different regions, so that we are able to use the concept of a double glass window. So what we did, the interior window was with the green fluorescence protein material, and then outside we use the phycoerythrin. And here you can clearly see that short circuit current on the cell depends on the temperature. This means that we are able to set a temperature sensor just by measuring the short circuit on the cell. This is how our application is working. So this is a mobile app that we are using to measure temperature in our lab, okay? So you can see this is in fast motion, you can see that this is a thermometer, a commercial one, and we are measuring based on our optical performance thermometer powered by the sun, as I mentioned, and of course we are comparing it with a commercial value to ensure how this is working. Okay, so the challenge for us, and it's I'm very proud to present to you today real-world side devices. So what I decided to do last year, we were very lucky because we awarded with a project that allows us to think in prototypes, only prototypes. So our goal was to make a real-size window, at least 50 centimeters per 50 centimeters, which is also an optical temperature sensor for build integration and connected to the IoT network. This is a joint project between University of Aveiro, CICECO, and IT. Because sun is not there all the time, night also appears, what we decide to do, we want our sensor to work also during the night. Because if you think in buildings, and if you think in heating, this is of course at night when people stay at home that part of the electricity is spent for heating the building. So what we decided to do was to contact a light engine company, which is a specialist in lighting, and our idea is the following. Okay, during the day we have the sun that excites our window, so we have our thermometer working. Remember that the power that the cell is giving is enough to allow us to measure the temperature, and then at night, of course, what we did, we use LEDs on one edges of the window, and we can also have this sensor working at night, with the advantage that this light can also be used for lighting, for interior light. And also, this is our first prototype. This is a photo of the campus. I think you can see it was not sun, it was last week, okay? You can see that it's transparent. We have already the LEDs on the borders, also the photovoltaic cells. And here, just to show to you that we have also some colored ones. So we have on your left a green film, and here we have a double coated window that can turn from the red to the blue, okay? And the last example that I would like to show to you is this double window prototype. Can be white, can be green, can be red, okay? It depends, of course, on the time and on the illumination that you are selecting. So, take-home message. Luminescent solar concentrators are a viable solution for sustainable energy systems, with additional advantage of promoting the urban integration of photovoltaic devices. One of the most promising solutions to achieve zero-energy buildings in highly populated areas, the rooftop are not sufficient to harvest and generate all the required energy for building needs. And my last message is that LSGs show their potential for modernization by recently reported connection to the IoT. And finally, this is a very general slide in which our idea, and this is a project I have in hands and that I would like to share with the RISCO researchers, what typically we are doing. So we are monitoring the temperature just with the smartphone or the CCD cameras from the surveillance CCTV cameras, for instance. As you can see here, you have the transparent QR codes that only gain color when you flash the smartphone light into it, so you acquire the temperature, and the windows are also providing temperature in real time, and we are sending all the information to a server where we are collecting all the data. This is very important if we think in the step of the zero energy buildings, that is post-occupancy evaluation. Typically, it's done by surveys, that was already mentioned today. People are not very interesting on it. Typically, they tend to reply in a fast way. So here we do not need this. We just think that you can have all the surveillance system collecting temperature values all around the building, inside and outside, or your mobile phone. So you have a huge amount of data. You can start to learn the difference between the projected building, how it was projected in terms of energy, and then how it is operating use. This can show to us trends of how people is interacting with our building, the materials resilience also to time and damage, and something very important that we just spoke. We developed also an app in which every time people decide to increase 1 degree in temperature inside each house, it shows the CO2 gas emissions, the price on the electricity at the end, and also make some suggestions to keep the comfort, the thermal comfort, that is very important, and that is, of course, dependent on the people. So our idea is to create awareness of the energy that is spent in controlling the temperature inside a house. So finally, I would like to thank your attention and, of course, all the people that is involved in this project. Thank you very much.
Thank you very much. Any questions?
I just have a quick comment and a question. Every time I came up with pencil down the question, you had the answer right away, so that was a problem. But a general comment and a final question. A comment has to do with the use of all this information, which is very interesting because, as you said, people will get tired over time of interacting. So there's so much you can do with people, and all this information is very interesting because we can use it for forecasting. Because as you just said, 1 degree or 1.5 degrees makes a difference in terms of internal comfort conditions. So this 1 degree is so important. And in this information, if we can use this for forecasting models, we do this in our group. Forecasting was very, very interesting to understand exactly how I can use this data with outdoor data and then forecast and have some measures being done, for example, closing a window, then putting the heating on at a certain time period because the energy is off peak, it's cheaper. So I see here actually an opportunity to collaborate in this sense with our forecasting models. And the question has to do with the renewables always have these struggle with these two, I would say, features, which is production or the intermittency of the wind and sun and the storage. Right? Mm-hmm. There are two problems that are coupled together. So I think it's a brilliant idea that you have the ability to produce energy during the day, use it or store it in off-peak, and then use the LEDs in the night period from the storage. From the storage point of view, is this feasible? Because it's still very expensive to store, right?
Yeah, this is a good question. Just remember that I'm speaking all the time with low power voltages, so the storage is very easy. First, during the day, as you mentioned, we are using the sun. Is there, no one, this window is not using it at all, so we are using it, and it can be used at least to sense temperature, and I didn't mention, but the physical properties that are changing here, they are also dependent on other factors such as humidity, so the same material can in fact sense a lot of different physical parameters and also chemical gases, for instance, and gases. What I'm trying to say is the question of storage is not a problem because the amount of energy that will be released will be low. But my suggestion is that this energy that is generated during the day, and for instance today it's a cloudy day, but the window will work exactly in the same way as if we have focused the sunlight into it, which is really an advantage. All of us, I believe, you know that today the water will be not as warm as if you have a very bright sun. This will not happen here, and this is one of the advantages. It is a film where we use exactly the same windows that are already in there. And the question is that if you want really to storage, for the moment we are not thinking about it because the amounts are low and they can be used to power your mobile phone, to power our LEDs, and something very interesting that we did. For instance, our idea is that at night in our room we can have the LEDs on the windows, so they also help to light the room. Okay, so you don't need, and this is self-powered, but you need to trigger it. Okay, so the small battery that could have been charged during the day is enough to trigger, and then it's on cycle, you see? So the question of harvesting is not really a problem in terms of you need very, very expensive or large batteries because the power is all the time small, and it can be using during the day. And the LEDs, they are really very low power devices that can be supplied by it. And just remember, this is 10 watts per window, and this is with the very conservative figures of merit, the huge amount of power, electrical power that you can have in our buildings.
And how far is from the market to put this in the market?
This is an interesting question. Although I'm presenting here prototypes, I do fundamental research, okay? But I'm in physics department. I'm also a physical engineer, and I thought since the beginning that I'll try to pick the best sample, whatever that means, and try to do a prototype because I teach students from physical engineering, biomedical engineering, they are all engineers. So this was growing, you see, this was growing, and like I mentioned, the proof of concept projects were there, this typology. I never applied. I did not apply for PRR, for instance, so I decided to apply to this proof of concept, and this is our first window, and we are having contacts from some companies, and the point is that on this size it is working, it is operating. The main point here, and that we really need to address, and this is the problem of the sustainable materials, and is the stability along the time, okay? So the materials that are based on the polymers, polymethyl methacrylate, optical fibers are there, no problem. We can use very few amounts of lanthanides. Now, from the fundamental point of view, what we are working with, and Sonia Ventura is here, is one that is helping us, and is in fact one that is extracting these molecules. We are trying to stabilize them so that we can have endless, or at least for a long period of life. So for the moment, I see that we are close in terms, we have a working, a functional prototype with large dimensions, operative. This prototype is working for more than 1 year, so we have data from the temperature inside of our lab for more than 1 year. And it's very interesting, the lab faces north and south, and the temperature values between are really different, of course, the orientation. And the fact that we are monitoring the temperature outside and inside is really, really, really interesting. And sometimes it already told us that one of the windows was broken because the temperature inside was all the time not as in the other window. So we noticed that one window was broken just because of that. So again, this has a huge potential. There are companies, as I mentioned, that are interested in it. Let's keep working and let's see how far we can go.
Okay, thank you very much. Next presenter will be the young guy.
Okay, thank you very much for your attention. I'm presenting here something which is not as fundamental as the previous research, something which is much more applied. I think it's a good example of cooperation between the university and other companies. I think it's a good example of cooperation between researchers, different researchers within the civil engineering department and outside of the civil engineering department. So this is a project which was led by Oli, which is a good company here in Aveiro. They do a lot of research. Also with other companies with us, Paulo Jorge Ferreira, which were also co-promoters in this project, and university, so University of Aveiro, PIEP from University of Minho, and within the team here in Aveiro, so it was me, Miguel Moraes, it was also Professor Ana Velosa, Professor Inês Meireles, Professor Reitor Costa from TEMA, from the Mechanical Department, and some researchers, Hamad Katmandu, Jaman Val, and Susana Ferreira, which also did the work on this project. The project was quite broad in terms of what we were trying to achieve. I'm going to present a small part of it, which is this development of a wall for a partition wall, an internal wall, focused a lot on rehabilitation. But there were other things which were in the project which we had to put together to make everything work together in a way. So measuring and monitoring consumption of all the equipment which were in the toilet, in the bathroom. So this was a little bit focused in doing a bathroom, a toilet, optimizing the energy and water consumption, guaranteeing a high environmental performance solution based on life cycle analysis. One big part of the project was using a narrowband Internet of Things to monitor air quality and monitor the use of the toilet. So it was developed some systems to monitor the flushing system and water consumption in the toilet. There were also a part of the project which was using additives to protect the pipes from limestone deposition. So as you can see, it was quite broad. I worked mainly in this wall which was developed. That's the main thing which I'm presenting here. So the idea is to build a modular wall system, so internal wall, and we developed the concept, we developed the idea together with some of the other partners, and then we did a lot of experimental tests. So this is a sandwich panel, and sometimes it's difficult to model its behavior, so it was necessary to do a lot of experimental tests, and that's what I'm showing a little bit here. So the core is XPS, so it's the sandwich panel with a core of XPS. It has in the bottom, it's possible to put all the drainage and all the pipes, so it's a technical duct for putting all the plumbing and so on. So you can put it or not. So if it's needed, you can use it or not. And then there are two face sheets which we can use different materials. The idea was to build something which is lightweight, easy to transport, easy to apply, industrialized. So the idea would be to industrialize a little bit the construction as well. I think we have a lot of construction which is needed, and we don't have manpower. People want to work in industry, they don't want to work on site. So I think it's something which, in terms of something which we have to address a lot. So industrialize the construction and transfer the construction from site to a factory, which gives us much more sustainability in terms of economics, in terms of social sustainability. So you get better quality of work for people. So I think it's something which is quite important. Industrialization of the construction. Something to do as well with do-it-yourself in terms of systems. So this is something you can put together and building it like blocks, like Lego. So the standard size of the wall panel is 60 centimeters by 2.4 meters height. So the idea would be to build something which like 2 people can carry it, 2 people can apply. The thickness of the core is 10 centimeters or 14 centimeters, depending on whether you have to put use the duct to put the drainage pipes inside or not. Core material is XPS, so one of the partners of this research produced XPS, so that's one constraint we had in a way, but it sort of works. And face sheets we used were gypsum plasterboard and magnesium oxide board. So we studied other materials, but these are the ones we used for our experiments. So we built a few prototypes. So the idea is that, like, there's a male-female way to build this, and so they fit to each other, and then you basically have to treat the joints between the panels, and then apply the finished surface and paint it like you do for normal plasterboard walls. As I said, so we did a lot of experiments, so functional tests. Basically, we did the test we thought it was required. So there's a hard body damage, there's a soft body damage. So everything performed well. We also did experiments on eccentric vertical load. So if you want to put a shelf in your wall, so if you can do that or not. So we had a good performance for 50 kilos, for 100 kilos. It's a bit more complicated, but I think for that you need a structure inside the wall. We also did some compression load tests, although this is not a structural element, but a little bit to see how the channels for the duct would work. So we did some compression tests. So they took a fairly good load, so 14 kilonewtons, 19 kilonewtons. So if we're comfortable with that, I think it's much more than what the wall will need to stand. Being partition, a wall which is to be used in a toilet, so we tested and we put a sanitary appliance load test where you put 400 kilos of load in to simulate the basin, and we use that. So there's limits in terms of information, and everything was okay. So we managed to get the loads, and the deflections were less than what's prescribed by the regulations. So it was complicated in a way. I think nobody, especially in the company, believed that this would take the load, but it wasn't much of a problem, I guess. The sandwich panel behavior works really well. We also did endurance cycle tests. So we did 10,000 cycles of 150 kilos. So this is 1 minute loaded, 1 minute unloading. So we had two testing apparatus. So you can see here, so you put the load for 1 minute, and then take it out for 1 minute. So the deflections were within a reasonable value, so we're comfortable with that. Also, we did fire tests, so using the department, the laboratory of fire, so Professor Villarreal and Professor Nuno also helped us with this test. So it's not, XPS is not a very good material for fire, so the idea was always to protect it using fireproof plasterboard and MGO. So we got like 29 minutes in terms of the duration of the test. So we did 3 tests, which corresponds to EI 20. So I think we find it's okay in terms of the fire test for a normal partition wall. We also did some acoustic tests. So we wanted to understand a little bit the behavior of these sandwich panels. It's not always easy to model this in terms of in computers, so we did experimental tests to understand the behavior. Again, it's not brilliant, the values we got in terms of insulation. Of course, depends on where the walls are. If you need more than this, you can use acoustic blankets, so we need to upgrade the system a little bit with using other elements in the sandwich panel if you want to use it as separation between two different houses and so on. So this is basically a project which works with many people, and it was somehow difficult time because during COVID times and so on, but I think we managed to reach the end. So thank you very much.
Any question?
So this system, you looked at me right away. So this, this system is highly dismountable at the end.
Yes.
So you can uncouple, I would say, the gypsum wall boards from the XPS, and obviously everything else is also, but it's highly dismountable.
Yeah, the idea would be to do something which you can build by yourself and you can take it out and reuse it. Yeah, possibly reusing as the whole module, as the sandwich panel, which is the easiest way. So yes, the idea would be that, because normal partitions wall, you build a structure with light steel framing channels, and then you put the positive boards, and when you want to take it away, you just basically take it all away and take it to the dump. This one, the idea was always to maybe also reusing it, the system to be reused, and less intensive in terms of work, and less intensive in terms of, like, you can industrialize this, you can do the panels, just need a press, and basically you can do the sandwich panel easily in terms of construction.
No more question?
Okay, thank you very much.
Now is Professor Fernando Neto from TEMA. It's a research unit from the Department of Mechanical Engineering.
Okay, good morning, and thank you very much to RISCO Direction for inviting us to be present in this very useful event. So, I'll be talking a little bit about TEMA, the Center for Mechanical Technology and Automation. And this is a sort of institutional presentation, but I'll try to detail some of the projects which are related with energy use and energy storage. Let's see if it works. Está funcionando.
Todas aqui ao meu computador.
Isto qual é para trás e para frente? Okay, so this is where we are located. We are distributed in 3 different places. So here at our main building, it's over here. Is it working? No.
In the middle button.
Oh yeah, right. So, my fingers are too big for this. So this is where we're located, main building. We also have a facility here, and nanoengineering is located over there. So this means that we are very close to RISCO. We are neighbors, and we are neighbors not only in a physical sense, but also in a research sense. So we have a lot of interactions. We have quite a big number of joint projects, and also not only on research, but also on lecturing. So we are neighbors in a more wide sense than just the physical one. We have our strong point is to provide research that can be applied to technological needs of society, and our director is Professor Antonio Bastos, and this is the structure of the direction of TEMA. So basically, our research is basically divided in several projects: sustainable manufacturing solutions, technologies for well-being, and the research infrastructure itself, which we call ITEMA. So under any of these great areas, we've got specific research fields for the sustainable manufacturing solutions. So we've got the division between manufacturing, processing, simulation, and engineering and bio-inspired manufacturing, and manufacturing for circular economy. And under the technologies for the well-being, we address multi-scale technologies and devices for medicine, environment, and energy, and innovative technologies for smart cities. So I gather from what you have already learned from the previous presentations, I think we are complementary. We've got a complementary role, and you also contribute to our knowledge, and we ask other research units to help us in the prosecution of these objectives. Of course, there is something which has not been referred, since there is also a particular role that we play, which is, and it has already been mentioned before, it is systems integration. It's fundamental for us because we have so much diverse areas to give a good role to integration. Currently, we have 150 members. We are running 60 projects, and last year, this is for the indication for 25-21, 310 research articles. And we became quite recently founders of the Intelligent Systems Associate Laboratory together with several other entities. Also a part of our attention is allocated to the services that we can provide to the society. And so we've got several labs, and we provide different types of services to the companies or institutions which look for these specialized services. And so this is also an integral part of our activity. Now, to some recent projects that I would like that maybe illustrate the overlapping or the complementary efforts that we conduct at TEMA with other research units, especially related with the use of energy in buildings, which is, for me, from my personal point of view, it's a very interesting topic and a very actual topic. You just know, just recently, the European Parliament has redefined new goals for the use of renewable energies in buildings. So we are faced with new objectives and new challenges, and we have developed some projects that might contribute to achieve this objective, and where complementary action with other research units might prove useful. One of them is this one, which is a modular facade with several purposes. So it's scalable facade. It can be adapted to any building. It can be used for water and space heating, and also for building ventilation and cooling, because it is coupled with a geothermal cooling facility. So this is a real scale prototype that we developed and we have been monitoring for quite some time. It's located close to Oliveira de Frades. This is a service company, and this is the main installation of this service company. And this facade satisfies, it's a solar facade, it satisfies almost all the thermal energy requirements. So it means that we have, at this stage, according to the monitoring that we had, we could extract in terms of hot water about 80 kilowatts of instant power of 80 kilowatts from this facade. Just to give you some scale, this is a 200 square meter facade. It can simultaneously warm up water and air, so water for heating or for sanitary hot water, and air for space heating. But it can also help in the building ventilation, because you can get a chimney effect on this facade, and also cooling of the building when we integrate the geothermal cooling devices that we've got coupled with the facade. So we've got several aspects during the manufacturing process. So this is where it started. So this is an external view of the metallic frame to support the facade, the view from inside, during the assembly, and finally the final project. So it has been in operation for about 2 and 3 years, but we have been continuously, we have kept a monitoring system on the facade, and we've been continuously monitoring the behavior of the facade. So this facade addresses the role which might be played by solar thermal, which is normally, as compared to photovoltaics, it's usually the poor relative of the solar energy, but does not address, although we've got a 2 cubic meter water tank storage facility, it does not address the issue of storage. So, of energy storage, which is quite relevant. As it has been mentioned, solar energy is intermittent, and it's not always on. And what we decided for the next 2 projects that I'm going to show you is why not use thermal storage or electrical energy storage is expensive, it's not readily available. And the reasoning for the next 2 projects was why not use regular equipment to store energy. And we've done that with, by using a normal water tank device, just to increase its storage capacity by adding PCM, phase change material, to the inside of the tank. And what we have done here was to use a regular equipment, which can be purchased anywhere, and to enhance its capabilities of energy storage by resorting to phase change materials. So this addresses the issue of energy storage without compromising the space available for the device, and using an existing device or something similar to an existing device. You can use this device to store additional energy, because the capacity of the phase change material to store energy is much, it's bigger than the capacity to store energy by water. And also another project that deals with, not in this case with the thermal energy, but with electric energy, was to use, I think people do not associate a cold freezer with energy storage, but the thing is we can use a device like this, so a deep freezer, a regular deep freezer, to store energy. How can you do that? Well, basically this product was jointly developed between TEMA and the company. It had 2 main roles. So the company wanted to sell these products in countries, in developing countries, where the electric grid is somehow not as good as what we've got here in developed countries. So blackouts happen quite often. The quality of the voltage is not always the same. So they wanted to develop a product which could be fed by a photovoltaic panel. So the compressor could be fed by a photovoltaic panel. And also we had an additional function. So this equipment could also be sold in developed countries, provided if you wanted to have either a photovoltaic panel to feed directly the electricity in the freezer, or if you have periods when electrical energy is cheap and you can store electrical energy as heat, in this case as cold, inside this device. So again, we resorted to phase change materials, in this case a different type of phase change materials, and the basic operating principles, so you can see the assembling of the phase change materials in the production line, how we put the phase change materials. This photovoltaic panel was maybe 1.5 per 90 centimeters wide, so it's a very small photovoltaic panel. And what we achieved here was 2 things. First, we achieved, because we are using PCMs and we are storing energy as cold, we could achieve an enhanced autonomy for this deep freezer. So our gains in autonomy on the freezer exceeded 50%, and by autonomy is the time it takes from one of these freezers to go from minus 18 degrees to minus 9 degrees. And this is a critical application for countries where electricity is not as readily available as we are used to. So the autonomy is a quite important issue. And we also managed to reduce the energy consumption by roughly 40% on this, not the cost, but the consumption itself, by 40% on this device. So these are just examples. We will not go into further, but I'll be available to explain a little bit more about the operating mode of these devices. And these are examples of what I think illustrate the previous cooperation with TEMA with other research units and might highlight some cooperation prospects for the future. So thank you very much for your attention. Thank you.
Any question? I will say quick question because we got a bit delayed.
The quick question I have has to do with this the last project.
Yes.
It's always we talked about this in the beginning of the session. Discharging.
Yeah.
So in those cases that you showed the use of PCM, the discharging was passively done. Was it
Yes.
stimulated, actively done in this last case?
It was passively done because we are talking about a different type of PCM. This is a PCM which is used for below zero applications. So in fact, this is a salted solution, a concentrated salt solution, and it's easier to supply and to extract it from these salted solutions than from a PCM which is designed to operate above zero temperatures, like something which comes from paraffin. So that was not a critical aspect in this case, in this particular case. Right?
Okay, thank you.
Thank you.
Next one will be Carlos Couto.
Hello, good morning to everyone. So I'm here to present this new research line about machine learning. In this case, it's mostly applied to steel structures, so application of this technology. But there is also some fundamental research going on behind the scenes. I will spare you from this because it's a lot of mathematics, and that's it. So I believe that everybody in this room has applied a machine learning model. In fact, this is a very simple one where you have some samples, some points here, and the objective is to fit a line into this model, and the machine will be trained to find the slope m and the bias b, so you can find this line here. And this is a regression problem, so you have a sample that has a certain feature, the length here in the x-axis, and then you have a target value that in this case it's x on the y-axis. And when we do this, we have this coefficient of determination, the r squared, that gives you the accuracy of the model. So if this value is close to 1, the model is perfect, or if it's 1, it's perfect. If it's closer or as closest, the model will be the better. Of course, that in this case we applied some more complex machine learning models, neural networks, support vector regression, random forest, and also polynomial regression. This was mainly using some Python libraries, scikit-learn and pyren, and there is an ongoing supervision of a master's student from the computational engineering in the physics department who is currently developing some models using more advanced libraries such as PyTorch and TensorFlow. And this is the goal is to increase the granularity, so to go into detail of what we are doing. These models are often called data-driven models because they rely heavily on the data, and they are as good as our data is. So we need high-fidelity results, and also large amounts of data is necessary. And we also need some computational resources, and this is provided by the Rede Nacional de Computação Avançada. And I like very much to show you this penguin over here because it's also nice to have some Linux skills and also some developing skills, in this case using the Python programming language. As I mentioned, I'm going to show you mainly 4 case studies. The 3 first ones are more related to show you, or my intention is to show you that these models are very accurate, surpassing the analytical methods when they exist. And there is also the possibility to use these models when we don't have these analytical ones. And we often call these low-cost models because they are very efficient from the computation point of view. And this will be the last case study that I will show you. So for the first case, you see here, and there is the correlation coefficient that I mentioned in the first slides. So the R square for the machine learning models on the top row and the analytical models on the bottom row, and this is for steel beams at normal temperature. And you can see here that these machine learning models really surpass largely the ones from the analytical methods. The ones existing in the Eurocode, new proposals, it's the third chart on the below row, and also some proposal that I'm developing with Professor Vila. So this can be improved in the future, but this is on the analytical side. Next is a study with my colleague Luca Possivent from the University of Trento, which is a member of the SU University. And this is for bracing systems that can have different cross-sections, as you can see here. And again, this is to show that the machine learning models have a much better correlation compared to the analytical ones. Luca was developing some analytical methods that are better than the ones in the Eurocode that you see here in red. And also there is some comparison in the different format, in the shape of buckling curves. So this is the existing analytical methods, and these are the machine learning models that we developed in this study. Next, and this was presented last year, this is the research with colleagues from the Johns Hopkins University, and it's mainly application of machine learning models to steel members with slender cross sections. This type of members, they have a complex problem going on between local buckling and the global buckling. And here we show again that the machine learning models that you can see here are better than the ones from the analytical models. But there are something that we need to take consideration of. For example, the support vector regression are not able to capture some different experimental results that we had. So it's KO, it's not possible to capture this behavior, so this model should not be used, for instance. And also the same results, but in a different format to show you in the different format of buckling curves. Next is the part of this application to the beams, and this is particularly interesting because this is a new proposal that will be part of the next generation of the Eurocode. It's a proposal that we developed here in the University of Aveiro, and you can see this is a great improvement from the existing rules, the actual rules at the present moment. So in the future, this will be the rules that you need to apply. And but again, we can see that the machine learning models are really very good to this situation, and they prove to be a very good solution and surpass again the analytical methods that exist. And this is again the representation in the format of buckling curves. Finally, to show you the last example, and for this I would like to give you a bit of context. This is a research project, a research project that is being developed between the University of Aveiro and Astron, that is a Luxembourgish company, and we were hired to develop a tailor-made software for them. And I think this is really interesting. Maybe next year I could be here just presenting this, because this is quite amazing. The state of the art of this problem was to have a calculation in around 4.5 hours, and we developed a model using finite element method, but we went really into the way how the matrices and the vectors are calculated, so really into the math, and we could reach a calculation time of 3 minutes, which is quite interesting. But if they need to do a 10-step optimization, so if they change the thickness of a beam and then make a calculation, then they change the height of the beam and do the calculation. If they do that for 10 times, then it's 30 minutes. So it's quite a bit of time, and if we talk about companies, time is money. So the idea is to apply these machine learning models to this problem. And one of the issues is that we need to codify this problem in the sense of the machine, to the machine being able to read what we are trying to do. So we need to codify this problem, and we reach the features. So this problem can be described by 9 features. But if we select 5 distinct values for each feature, we will reach a database of 2 million samples. So this is not feasible. We cannot do this. So, and this is a part of some fundamental research. We implement some smart sampling strategies using some domain knowledge. So we know the problem. We are engineers and we know the problem. And we implemented some constraints into the samplings, and we reach a more modest number of samplings, in this case around 6,100. And this, for each of these features, a random number generator is used. So for instance, you can have one sample that has a value between these two and one value between these two, and this is all random and complying with these constraints. Of course, that we have to validate this methodology, and we see that as the number of the training samples is increasing, the neural networks, which was the machine learning model used here, got or improved the results and start to converge to a good accuracy level. Another slide about this validation, and this is quite interesting. I don't know if I will be able to pass the message, but in the database of the training samples, we didn't have such things, so we didn't have a thickness variation so smooth, but the artificial neural network was really able to capture this very particular phenomenon that was happening. And this is also an ongoing supervision of a master student from the computational engineering, so stay tuned for the developments on this area. And of course, I started this presentation with saying that some Linux skills and some programming skills were important to have, but this is for the part of training and developing the models, because as soon as you have the models trained and developed, you could implement something into a very simple tool, and everybody can input the values here and press calculate to get the values. So this is really easy to use. And of course, that as soon as we have this tool, we will immediately try to benchmark it in terms of the speed of calculation. And the amazing stuff here is that one single calculation took around 1 millisecond. So if you remember before, it was 3 minutes to calculate the structure, but now maybe it's just 3 seconds. So of course that Astron was very impressed by this, and we are in the position of discussing the next steps and maybe launching a new research project. So that was it. Thank you very much.
Thank you, Carlos. Any questions?
Is this basically different from what we call generative design for structural engineering, what you're doing? Is it another way, or is it another way of saying it? And the integration of your work into Vila. That would be very valuable, taking into account you have a very strong industrial partner.
Yes, thanks for your questions. The last one is, I think it's really an interesting step to move into these BIM technologies. This maybe is an area where collaborations could be implemented. And the first question was about generative design. And for this generative design, you need a model where you can have a target value. So you want to optimize the solution, but to optimize, you have to have a target value. And these neural networks can be used for having this target value. So we will use them to optimize. And that's exactly what we are discussing right now with them.
Thank you, Carlos. Next one is the blue block.
Good morning, everyone. I'll try to make a fast presentation, so I know we are a little bit delayed. So I will talk about the fire resistance of structures composed of stainless steel members. This is a subject that me and Professor Vila have been working for some years, and for sure we still continue to work. As I will show, there is still a lot of topics to be researched. After a very brief introduction about the material mainly and its applications, I'll talk a bit about the fire resistance of stainless steel members, and then what we are trying to begin about the knowledge on the global structural behavior of stainless steel structure, and the fire, of course. So I could talk about each of these advantages. I will focus on the main one, the resistance to corrosion. Of course, everybody knows about the high resistance that we have on the stainless steel. These advantages and drawbacks are mainly compared to the conventional carbon steel. Okay. But in fact, I should highlight the better behavior at elevated temperature, as the topic is, of course, regarding the fire resistance. The drawbacks, weldability is not so much a drawback because it's more about knowing what material to use and what methodology. The design rules, well, we are doing research to improve them, so also not so big drawback. Of course, we all know that the initial cost is the main disadvantage. So typically we can have stainless steel that is 4 times or 6 times higher, more expensive than conventional carbon steel. Yet, regarding steel initial cost, we can save money regarding the corrosion protection and the fire protection. This I'll show. The fire protection, the corrosion is already known. Also the operational costs regarding inspection, maintenance, increase of the service life, and of course in the end of the structure life, we have residual value, whether to recycle it, it is 100% recyclable, or to reuse it. So for sure it will be more valuable than conventional carbon steel structures. We can have all types of products as we have in conventional carbon steel, so I won't go into details. Different structural applications, of course, they are more regarding the corrosion resistance that we have in stainless steel. So these are different structures that we have in stainless steel already, some bigger than others, of course. These are the stainless steel grades that we have in European standards. You can see a high number of grades, different grades with different mechanical properties. You can see here the main ones that I will focus on the presentation compared with the conventional carbon steel. They have, these 2 grades have lower yield strength, but higher tensile strength, much higher, and higher ultimate strength, much higher as well. This is important, the ductility, for instance, for seismic resistance. Regarding elevated temperatures that appear under fire actions, we can see here the reduction of the mechanical properties in function of the temperature. So the carbon steel is the lower one, as well in the young models, and the yield strength. So in fact, this is a fact, stainless steel behaves better at elevated temperatures. Here are the constitutive laws. You can see they are much higher than the carbon steel. The carbon steel is these ones. So this affects, of course, the resistance of the structure and should affect the design rules, analytical design rules formulation that we have in Eurocode 3, the standard for design structures, steel structures. So the fire resistance of stainless steel members, as I told, has been a research topic of our own for some years, but we have recently this research project with Service that was here yesterday, and with the support as well of Instituto Politécnico Bragança, financed by the National Science Foundation. And we had to do all the parts from the mechanical properties at elevated temperatures research, with tensile tests at elevated temperatures, with the new constitutive laws that we have to implement in numerical models, because the main objective was to develop design rules based on parametrical numerical studies. So this was like a basis of all the research. After, of course, to validate the numerical models with the experimental test, this was to members subjected to bending and the respective validation. Then we go to the plate behavior, plates that are composing then cross sections, eye cross sections, rectangular shaped cross sections. We've tested different types of cross sections from circular, elliptical, cold form that are not there listed, eye sections. We have this number of different cross sections with different parameters, material parameters, residual stresses, imperfections that we have to consider in our numerical models. Axial compressed columns and restrained beams where we have lateral torsional buckling, we have to consider it as well. The loading type was an important parameter to consider in this resistance. We can see here that we compare the numerical analysis with buckling curves. So this was our objective. The buckling curves are the design rules that designers should follow when they are designing structures, steel structures. Beam columns, members that has compression plus bending, and the fire situation as well. And now to go just a little brief presentation about the global structure behavior. We are just starting this part. We have done already some years ago some tests, but we are now more focused on going to this direction. And we are aiming at performing numerical studies, of course. We are dealing with real scale structures. We have to go to numerical analysis with this new constitutive law. In this software that we have used, SAFI software that we know this software we have used for a long time, and to develop studies on steel frames, multi-stories, 2D plane, or 3D structural analysis, also to take into account the progressive collapse. So just a small example, comparing these three stainless steels. I should remember that this is the 304. This is a nomenclature of this stainless steel, very known 304 and 316. This is 4 times expensive than the carbon steel, and this is 6 times, more or less. So this is a case of an office building with a fire in one compartment. And you can see here the deflection, yes, the displacements, more or less the same in terms of final, in the collapse instant, but the time is really different. You can see here the time that the structure resisted to fire, from the carbon steel 27 minutes to 78 or to 95 minutes in the different stainless steel grades. This is due, of course, to the constitutive law that has a big ductility and a very high tensile strength at elevated temperature. So we can analyze the axial effort diagrams, the bending diagrams as well. And so these are the results. I will not go into detail to them. It was just a brief presentation of what we are doing, and we hope to do in the next future on this topic. Thank you very much.
Thank you, Nuno. Any question?
So how can you compensate with the maintenance? You think about compensating the overcost of stainless steel because it actually has very much better fire performance. How will you make up for the initial cost, maintenance costs? How will you?
As I showed, we can save already in the initial cost because of the corrosion protection that is not needed, and hopefully also the fire protection that is not needed. If we protect a stainless steel structure, we don't see the nice aspect that it has. So this is important. We can try to save in the initial cost, but also in maintenance. We don't need inspections or less low frequency inspection. Also the maintenance cost. The residual value as well in the end is, as I show in that slide, we have a higher residual value. I usually had this slide with the structure in carbon steel and the secondary structure in stainless steel in a bridge that has 3 years old, and the carbon steel structure is already too corroded and the stainless steel has nothing. So in fact the corrosion resistance is very important Even if the steel is protected to corrosion, sometimes the carbon steel goes very fast, and the stainless steel does not. I think the main thing is not saving in the initial cost, it's more in the maintenance and the really bigger life service of the structure.
Thank you. So the last invited unit is DigiMEdia, and this Nelson is about. Okay.
Okay, good morning, good afternoon. I'm here to present some projects that we have been doing in the past years, mostly done in the past year, 2022, on our research unit of DigiMedia. Okay, this research unit is specialized in the digital media design research. Okay, we research the big domains of user experience, human-computer interaction. We try to understand how people react to machines, how people use machines, and how people can be engaged with machines. Okay, so it's broader, but it's mostly oriented to understanding the humans as persons made of behaviors. Okay, our research team is made of 35 integrated researchers, 20 collaborators, and now around 50 PhD students. And mostly they are working around these three big areas. Okay, digital studies, digital experience, and digital content. In the domain of the digital studies, we are doing more fundamental research related to the theory, existing theory, and trying to understand new theories on the behaviors, the ethics, the effects and impacts of all these digital technologies that we keep building. In the digital experience, we are more engaged or oriented to the design of new experience. How can we design this new experience to maintain people interested in the subjects, to maintain people interested in the interfaces, in the machines, in whatever you build, okay? And then the last one, the digital content, is more oriented to the media side and is more oriented to create new formats for television, for film, for video online, for games. It's a big area, okay, and every year, every 6 months, new formats come, new technologies appear, and so it's challenging, it's interesting, and it's moving at a very quick pace, okay? So I will only present a small set of projects and only the applied projects. I will not enter into the domains of the foundational research because I believe it's not very interesting for the audience that we have here today. So in terms of the platforms oriented to the social systems, we have many systems related with social networks. You know for sure Facebook, Instagram, TikTok, and all these things. We have built a system like Facebook is called Campus for the schools. Okay, it's been used here at the University of Aveiro for the past 10 years. It's been supported by the Altice Foundation and it's been used by schools all over Portugal, higher schools, okay, not the university ones, and it's used by professors and teachers to share materials with the students. Now, of course, we have Teams, we have Google Education, we have all these, but it has started 10 years ago, okay, when there were no platforms like this available, okay? It's open, it's free, and people are using it and are still making it better or optimizing the engagement inside the tool through a set of approaches of communication, the socialization, the gamification, storyfication, and other approaches, okay? The GPS is the global Portuguese scientist, is a social network that we built 3-4 years ago. The idea is to bring together the Portuguese diaspora working in the research, okay? And so connecting all the people that it's outside of Portugal. This was made with the foundation of Pingo Doce, the Ciência Viva, and now we are changing the managing structure in order to only be University of Aveiro and FCT, okay? So it's if you go there, there's a lot of information there, but it's not a lot of dynamics because it's been in a hiatus for the past 4-6 months with the changing of the management system. The Mion is one social network created for older people, okay, elders. It's been used for the past 2-3 years in the region, okay, connecting all these older, how do I call it? Not too older, but it's these places where older people go to spend some time with other people. And so this tool wants to build beyond these places, okay? People go there, they stay there for 3-4 hours, then they come back to home. This tool try to bring them together when they are outside of these places, okay? And then the last one is the Smart City. Is a kind of new dashboard to interact with all the information that you have about a city, electricity, wind, time of weather. It has a lot of data points, a lot of sensors throughout the city that are connected to the system, okay? The main innovation here was to find out what would be the best interface approach, okay? Instead of presenting tables and regulators, presenting something that people can very quickly understand what's happening in the city, okay? So everything here is dynamic and moves in terms of the way that the data is coming into the system, okay? So to move a bit faster, we have another area, is the digital television area, okay? Where we work with social experiences. We have a lab where we do experiences with people watching television and interacting with television and many other systems that connect to the television ecosystem. The main 2 points is how to create these new interactive programs for television, and the other part is how to connect the experience of watching television between us and all the other people that are also at that moment watching television. So instead of you being alone watching your television, you can be with your colleague that's 5,000 kilometers away, also watching the same program, and you keep discussing and talking with each other, okay? Another area is the digital games. We have many games being developed at our research unit, okay? Some of them are related with, most of them are serious games, are related with subjects that are needed to be transmitted, taught, conveyed in any manner, okay? One of these games that is ending now is the flavor game. Is a game that puts together, we call this a new kind of game. It's an hybrid game that brings together tabletop, digital, and also food, okay? So while you play with cards, you use an interactive system, interactive digital system, but you also use real food to play the game, okay? This was made for kids. It's a project, it's FCT funded, okay? It was made in order for help kids to open their interest in food, okay? Because kids normally at the age of 10 to 15, they try they don't try, but they tend to eat only the things they like, okay? Because that's the food they know. And the food they don't know, they normally try to not go too near, okay? So what we do here is create a set of conditions that change their behaviors towards the food, okay? they need to taste the food, so they need to change their own behavior to understand how the world works, okay? And the last system here on the side is a system that helps people build games, okay? So another FTT project is a tool that we give to communities, and communities can use to very quickly start creating an activity that uses games mechanics, okay, that help them engage people towards the objective they have for the company. And the other one on the other side is one with virus, okay, is a game talking about virus in our world, okay, so you are a kind of a scientist and you need to catch all the virus before the virus create an epidemics, and so it's a way to teach kids about the problems with the virus, okay. So normally we don't use gamification as a very simple system of points, leaderboards and badges, okay. This is too much behavioristical oriented, so it works in the beginning, but after some time people just disconnect, okay. So now we go deep, we dig deeper and we try to bring the mechanics of entertainment inside these serious games, okay? So one another area is the cultural heritage area, where we work with preserving some patrimony, some cultural heritage, and we have some projects around this, okay? One is now being worked around the village of Almeida, is one village that some of you must know, is in the frontier of Portugal with Spain, has a very big structure, but a lot of the structure is also destroyed, okay? So we built augmented reality where you can enjoy the visiting of this place and see how the village was really 200 years ago. Okay, so this castle here doesn't exist there, but while you are going through, you can use your mobile phone and see how the castle was there, and how was the entrance, and how can you visit all these spots that were being used through the confrontation that happened there 200 years ago with France, okay? There's also some other projects, Royal Treasury Museum. This is a museum in Lisbon where we have created a set of multimedia objects for the museums. We have a lot of people, no, 2 or 3 people working specifically with changing the landscape in the museums, okay? Bringing into the museums a lot of multimedia approaches, not only visuals, audio visuals, but also some data visualization that helps to create a new type of experience inside the museums, okay? Because museums sometimes they are able to bring people in, but they need to have some kind of star artwork to bring people. If they don't have this star artwork, it's very difficult to manage to bring people into the museum, okay? So creating these kinds of new approaches to the presentation of the artworks can help them building a greater experience, and so bring people into their museums. And the last one is the AI. We don't build specifically models of AI, okay? We work with them, and we analyze and study them, okay? We analyze how people use all these models, how are they being used now, and you know for sure that the past 6 months have been a bit crazy, okay, around all this area, because all new things are coming up every week, sometimes every day, okay? So we are trying to understand what will change in our own lives, because it will affect all of us, okay? It's not only the people that do regular stuff or repetitive stuff, it will affect all of us. So we are studying that in terms of their impacts and also in terms of the ethics, okay? Because there's a lot of problems behind the artificial intelligence at the moment. We are now producing a cycle of dialogues that started in March, okay, and is going to till the end of May. We have some workshops around the themes of creative media, programming languages, pedagogical approaches, and the last one is about the ethics, okay? And we'll have then a final session by the end of May, where we'll try to wrap up all the areas and present some solutions for the University of Aveiro, okay? And so that's it. and I'm open to any questions or whatever. You can send email to me or to DigiMedia, and I hope we can find some connections within the two research units. Okay, thank you for inviting me, and see you in another possibility.
So, any comment or question?
In your projects of augmented reality, do you just show the material of heritage, or you also introduce narratives, cultural significance, more
Now we build the entire experience. We try to, the idea, of course, augmented reality is fantastic to present how things were in the past and to bring some visuals and other visuals, but the idea for us is to create a full experience. At the moment, the experience I was presenting to you is being used to test 3 different scenarios. One where it will be game-oriented, the other will be narrative-oriented with stories, and the other one where it will be creative-oriented, where you go through the castle and you are building things. Okay? You are not being told a story, not playing a game, but you are building things with the information we are giving you. And so we are measuring what the difference in terms of engagement and the gains at the end of the experience. Okay. Thank you.
So the next one is Anna Bois from the RISCO unit.
Well, hello and good morning, afternoon. Today I will give a presentation not actually on a research project or a research output, but more on a research line that we have started, complying the areas of conservation, risks and sustainability. This was actually something that we were asked to perform together with the historical villages in Portugal and the Association of Architects from Central Portugal. The title for this is the Sustainability of Traditional Construction Elements in Central Portugal. And we are working in a very small group, from the university of 3 people, 2 engineers and 1 civil engineers and 1 architect. And we have this prospect of giving the historic villages and the territory a territory that is very much in need of people and of intervention, some perspective towards the future. And so here from the University of Aveiro we have a person from IDMAIS. This is another research unit that is not here today. And this is quite usual to work with other research units. And we have Hugo Rodrigues, who was working together with me from the department and RISCO research unit. So what is the actual state of this territory? We have a photograph of Almeida as well, because we are also working there. We have 12 villages in central Portugal, and they are widespread in this area, which is on the other side of Serra da Estrela, so it's a bit difficult to get there, and this is just on the frontier with Spain. So this is quite a special territory in many ways. On one hand, obviously, because being so near to Spain, it has lots of monuments and specific constructions. On the other hand, because of course, if it's harder to get there and it's just a frontier region, it's got less people at the moment, and mainly villages, small villages, and some very, very specific problems. So to get a general idea, I'll try to be quite quick about this. This is more or less the original, not completely, but the original characteristics of building in public space. And we have, this is a specific village called Pioro. It's built with local stone. It's sometimes schist. This is the only case where it is schist. There is another group of villages called the schist villages, and this is the only one that belongs to the group of the 12 villages. And they are mainly granite for external walls, and they've got timber roofs. But I'll go into the materials in a more detailed fashion in a while. So in terms of the heritage we have, as I said before, we have Almeida and other villages with very, very special heritage monuments, and they are, as a whole, trying to be classified heritage-wise. In terms of building materials, I'm going to look at the bright side of things here. And I'm going to talk about what is still in place and the building materials still in place. And of course, they have been interventioned. They were interventioned by architects a while ago, and this was quite good for most of these villages. But then the interventions that have been performed since are not so interesting, but I won't show them now. So what we have in terms, for example, of timber structures is very, very interesting. I will go through this. These are internal partitions, the walls, the granite walls, also some timber frames and timber doors, and all of these still exist. Also, in terms of the rendering materials, we have a variety which is very interesting. Of course, lime is everywhere. Color is also everywhere. Also, earth. Earth renders are very, very common, mainly on the inside, but also the outside, but mainly on the inside here. And we've got this, for example, this specific structure which is made, this earth render, and it's made with some vegetation, some stalks. So it's vegetation and earth and timber, of course. The same here with earth and timber on the outside in this case. Not earth, I'm sorry, this is lime. And more lime and color, and very, very common throughout these villages, something that is very special in Portugal, and that you can only see very faintly, for example, over there, because many of these have been painted on top. And this is a very, very special heritage that we still have, which is on the go, actually. So the proposal basis for these villages has two basic lines. One of them is very linked to this conservation line, which is authenticity and authenticity criteria. I will not dwell into this because most of the people here are quite aware of authenticity criteria. And so we'll just talk very briefly about the technical guidelines from UNESCO and just in point form what they point out as critical. And for example, the materials and substance are obviously critical in terms of integrity and authenticity. So this has to be something that these villages need to incorporate in whatever guidelines they might have for the future. Also sustainability. And although the integrity criteria has been applied in many monuments and so forth, sustainability is much harder. For sustainability, of course, we have the choice of materials, which is very easy for us. They made it very easy for us because of all of these traditional materials are sustainable in themselves. So this is quite an easy task. For example, I have the lime cycle here. But on the other hand, we have to ensure that whatever we decide that is going to be used in these villages has low CO2 incorporation, low energy incorporation, an interesting thermal behavior, probably not the best, but an interesting thermal behavior, and a good effect on internal air quality. And we need to balance all of this. It will not be optimal in each one, but it will be balanced, surely. Of course, we have things like thermal inertia, and of course, we are very, very worried, especially in this territory, about indoor air quality. This is a huge problem we have in Portugal, and it used to be very, very good, very interesting with, for example, the earth renders on the inside, and the way that houses were permeable. But now we have some problems, and in this area we have specific problems. We're also concerned with energetic poverty, and if we see this map concerning energetic poverty, you can look at the red and blue spots, and you can see that this area has energetic poverty linked to summer and winter conditions. And so this is something that is also taken into account. But we have an issue, which is, of course, we have regulations, but maybe we should think about the fact that these regulations may not be directly applicable in this territory. And we must think about this for the future. And countries like, for example, Austria have changed their thermal regulations so far, and they have different demands in terms of what comfort is. And we really have to think about what comfort is inside these houses. And this is quite old, from 2010. This is from LNEC, and it shows comfort in terms of temperature based on a study based on people and how people feel temperature. And we all feel temperature in a different way. And the way temperature is felt together with humidity in these villages is critical. At the moment, we've got 2 master theses going on. Of course, this is linked to research. And one of them is actually measuring, together with Hugo Rodrigues, the temperature, the indoor air quality, etc. in these houses. Obviously, this is so obvious, but I had to have it here. We have the Sustainable Development Goals linked to the measures that we are implementing in these villages. And the intervention will have to take into account the preservation and reuse of materials, the conservation and rehabilitation of these villages, but we also want to work together with these old, implementing new solutions for new old solutions, picking these old solutions and implementing them in a different way, taking into account comfort also with the water issues and heating issues that already existed there, using innovation for tradition, and especially listening to people and having into account what people want in these villages. For this, we went through all the villages and talked to all the communities before we actually started working on this. And we will talk again to these communities before we actually implement anything on site. More than that, we have another critical issue, which is the depopulation of these areas, and we just submitted a research project to La Caixa in which this factor of depopulation and the social factors were the most important ones. Here I brought a picture. This is Bussaco, and this is something we did here at the Civil Engineering Department as well, which was a specific rehabilitation of this small house. Quite amazing, actually. I don't have pictures from the inside though. And with cork and tiles and airline materials, and this was actually a summer workshop, and we plan to do things like this as well in the historic villages. We also have the perspective of another project that they have asked us to join, and this is going to be transnational, also having the Spanish provinces as well. They have more or less the same problems here. So this is a link between the social problems and the more technological issues that have been brought along in this session. And so we have we're working together in this specific case with this group. But it is a huge, huge group actually. But these are the main actors of the group that we've been working with. So thank you very much.
Thank you, Anna. Any question? This is quite a huge work.
Yeah.
What's your time foreseen for this work? I know that you spoke with the population and then you're going to speak again. So is this a long-term project? Is there some included some rehabilitation of some pilots there?
Well, we hopefully will have 2 further projects, and if this happens, we'll have another 3-4 years working on this. So I really hope this goes on, and that we manage to implement them. Yeah. We're actually working with a pilot with master thesis right now, so we can have thesis working on it as well.
Thank you very much.
So last but not the least, António Figueiredo from RISCO unit. So please try to.
Well, hello, good morning to everyone. I'm going to be really fast because all of you, including myself, are thinking having lunch. So my name is António Figueiredo, and today I'm going to talk about fostering energy transition challenges, innovations, and also solutions. Well, in this sense, I would like to start this presentation by showing the manners that we are getting and using our energy. And in this plot, it shows the global electricity consumption on a daily basis. And I'm not talking about only the building sector, I'm talking about the entire economy. Now, if you look to the orange curve, we observe a change resulting from the introduction of renewable energy sources, which are extremely dynamic and sometimes very difficult to predict. And in addition, they have an intermittent behavior, especially if we are talking about solar and wind energy. And this curve is called as a duck chart. Now, if you look to the energy that the buildings are consuming from the grid and analyzing the energy consumption evolution, well, with the introduction of renewable energy, we observe that the energy consumption on the grid nowadays it's so much smaller that sometimes we don't need any more the energy from the grids. But in fact, we cannot shut down the power plants because the power plants are designed for a certain capacity. And if you shut down a power plant, it may take a week or 2 weeks before you can put it back into operation. So it's really necessary to balance the streams to get our duck flying. So to overcome this issue, the solution cannot be one unique solution. And to overcome this issue, I bring 3 perspectives. The first one regarding energy storage, and I'm talking about materials development and constructive systems and solutions. The second perspective regarding alternative energy sources, and the last one regarding calculation methods. Well, in the first one, I'm going to focus in the incorporation of phase change materials. Everyone knows what is a phase change material, so I'm going past this part. This specific work comprehends the development of 2 mortars containing 2 different types of PCMs. This work comprehends also different levels of application ranging from the laboratory scale in the mortar's development until dynamic simulation and real applications. Well, regarding some results from the laboratory characterization in terms of materials, well, the first one is regarding mortar without PCM, and we could observe a linear behavior when we are getting the equivalent thermal conductivity in terms of temperature evolution. By adding the PCM, we can observe two different behaviors. The first one, a linear behavior in the solid and in the melted part, and a non-dynamic behavior due the addition of the PCM in the mortar. And even in the two solutions containing the same amount of the PCM, the behavior are totally different. Well, moving for the constructive solutions that we have been applying in buildings, well, with this second innovation, the constructive solutions consists of a light steel frame solution. This is due to the growing tendency for prefabricated solutions. Well, in this case, the PCM was added in these containers, in this box, into the constructive solution. Two tiny houses were built in Aveiro University campus here using these constructive solutions. The first one was used to be the reference one, and the second one, the PCM in macro capsules, was added in the walls and also in the ceiling. Well, regarding the results, just two highlights. The first one, we attain a peak temperature attenuation of about 2.5 degrees in the maximum and also in the minimum. Well, in the swing of the temperatures, in the amplitude, in a daily basis, well, it represents 5 degrees, comparing the solution with PCM without the other building without PCM. And also high levels of reductions in terms of heating and cooling rates was observed during the day and also during the night. We attain a shift in the load, in the temperature rate during the night. Regarding, for a new perspective, the alternative energy sources, and with this kind of energy, geothermal energy systems, well, we don't have the problems related like we have in the solar panels, because the geothermal energy is always available. Okay. Well, regarding these systems, we have been studying geothermal energy systems and their integration into buildings since 2012. The university has 5 departments equipped with geothermal systems, and focus this building, the CCI building. This building is equipped with a total of 42 thermoactivated boreholes and 2 energy piles. And regarding some results of this research, well, at a deep of 140 meters, we could collect temperatures more or less with 20.4 degrees. And regarding the energy consumption of the heating pumps, well, considering in average the heating and cooling, we get a consumption of 8.22. It's lower than a consumption of a passive house, for example. Well, regarding the last perspective, new approaches are needed to overcome the limitation of the standard regulations that are based on steady-state methods. So this novel approach should be based in dynamic simulation and also combined with algorithms. Well, I'm not detailed how the algorithms and how this approach works, but I'm just referring that this approach could be used for calibration models to really reproduce the real behavior of the buildings when we are simulating. And regarding the simulation, regarding the calibration, well, we tested this methodology in one building, one existing building, and we get a GOF of 3.19, a good of fitness. This methodology could be also used, for example, to optimize the phase change materials and the different values for exchange rates. And just combining these two parameters, well, we get a reduction in the overheating of 34%. And to conclude, another application of this algorithm could be in optimizing the windows area and also the overhang solutions. In this case, it was applied in 3 real buildings that was constructed in Brazil in 3 different bioclimatic zones. And in terms of results, well, a glazed area from the original project, from the original design, was recommended in 40%, and the shading elements, well, it's depending on the bioclimatic zone. So I'm finished my presentation just in time.
Thank you very much.
we can discuss during the lunch.
Yeah,
we can discuss this.
The lunch. So thank you very much. So now Romeo will close the section.
So I won't be keeping you too much time in the room, but before we leave, actually, I would like us to stay in the room for at least another 10 minutes so we can take another look at the posters that our PhD students prepared, and obviously have some water and have some snacks back that are back in the room. So very quickly to close off, first of all, I would like to say that our rector is cannot be with us, a last-minute call, so he could not be with us here at the closing session. He apologizes, obviously, and will talk with us afterwards in the afternoon about the whole event. And obviously, I will tell him that it went great. It was fabulous. So just let me finish off with some thanking. First of all, I have to thank what I would say is our secret weapon. A secret weapon is the researchers that are contracted by RISCO, and also Nilsa Lima that is helping us out since the beginning of the year. So they're really responsible for the very high and very efficient logistics of this event. Thank you very much. I would like to thank, obviously, the presence of our External Advisory Committee, because very important to us to be here, and obviously the meeting this afternoon, we can discuss what we've seen over these 2 days and continue under your supervision or your coaching. Thank you also, João Oliveira from SCIRP, for covering the whole event. I think we had a good number of people online. I think yesterday we had around 40 people. I'm not sure today, but it's a good number, and I'm happy about that. And I would finish off saying I'm very, very proud and very grateful to all the researchers and collaborators of RISCO, because what we showcased yesterday and today of our research was really, really good. It's not me saying it, it's the feedback that I got from here and there yesterday and today, and I'm really proud about this. And it's really great to coordinate a group like this. Thank you very much. Don't leave the room, please. Go back, have water, speak with each other. We'll go for lunch a little bit later if it's not possible, okay? You can go a little bit later. And I hope to see you next year in 2024 in a bigger room and with more people. So thank you very much.
Ou isso